Welcome to Zymorphine Scripted Synergies version 1.0 with a C# and Grasshopper webinar with Mateusz, who I'm sure many of you are familiar with if you're using Grasshopper. And this course is inspired by our master's degree course, Chapter 5, Cosmogony. And in this course, as mentioned in the website, we'll be looking at some basics of C# and working with agents to create these kind of structures that you've seen on the website and Instagram and some other things. Before we get started into that, I just want to say thank you for joining us on Valentine's Day, and apologies to your significant others that we may be taking you away from. So before we get started, I just want to look at our master's degree. If any of you have not seen it or are still interested in it, please go check it out. The early registration and scholarship applications are ending in 2 weeks. It's a 9-month-long, fully accredited master's degree online specifically for computational and advanced design, and Mateusz is also one of the tutors in this program. If you go to the page and you go to the team, and you can highlight on any of the team members' name and find out more about them, and you can read more about each chapter and lab. See application will bring you to the application page with further information about scholarships, etc. And you can always reach out to us about the master's degree program on masters@zymorphine.com. So please go check that out. Additionally, yesterday we launched 4 new webinars. Generative Topologies, which is focusing on Fusion 360 and Grasshopper for generative product design and optimization. We have Biomorphic Networks version 2, which is using a custom plugin specifically made for this webinar, which is looking at slime mold logics in Grasshopper. We have Fragmented Fictions V1, which is looking at Houdini in terms of volumetrics and VDB. And we have Elaborate Sinuosity V1, which is looking at Autodesk Maya with Nicholas Turchi from Zaha Hadid Architects. So please go check those out if you are interested. They're all with a early bird special right now, which is 25 euros each until the 20th. And you can see here on our Instagram how to get that early pricing by sharing this this image to your story and tagging us, and we'll send you the password to get that discount. So back to this class, I will introduce Mateusz here. So Mateusz is a member of Zymorphine, and he's also the founder of Object. Mateusz is a developer, architect, and researcher. He's also the author of the plugins Owl, Starling, Squid, Anemone, and Mesh Tools, and also many other Grasshopper-based plugins. And he's also a big part of the creation of Pufferfish in terms of consultation and some scripts directly. And he's the founder of the object consultancy Milkbox Group, which is a popular Grasshopper group. Longtime workshop tutor, teacher, parametric design popularizer. He's currently research assistant at the Digital Design Methods Chair BTU Katbus, where he is pursuing his PhD thesis on AI and architectural design. And before I hand it over to Mateusz, I just want to mention that this is a course that is, using C#, and even the most basic beginner courses of C# can be difficult. So do not feel alone if you feel a bit confused or behind or lost. It's 100% normal and expected, and that's why you will have also the recording of this session to view afterwards. as well as the support material that we've already sent you and the material that Mateusz will be creating during the webinar that we'll send you also afterwards. So again, scripting is not easy. So, just try to take it in, keep up if you can. If not, just watch it, try to absorb, and go back to the material at the end and ask questions in the Q&A box. But just don't feel frustrated if you can't exactly keep up right away. So I'll give it over to you now.
Yeah, hi. Good day and good morning for some of you, and good evening for some of you as well. I see that we have people from all around the world, which is a bit intimidating, to be honest, but I'll try to cope with that. Michael already introduced me, so I'm just not gonna repeat that. I think he said most of the things which I would say about myself as well. So. Uh, Yes, I mean, why? Like a sentence or two about why do we do this particular workshop? Like why I chose to do the C# workshop rather than any other workshop? Because you may know that we did maybe tens of workshops across a number of years together or separately as design morphine or as I did some workshops as object as well. And now I really want to focus on two kinds of workshops. So one type of workshop is essentially AI machine learning workshops, one type. And this is the thing which I'm doing with some students at some schools which I'm teaching at, like EAC, BTU, and volumes in Paris. But those are, and design morphine, I think we did a machine learning workshop at some point. But this is just one, and this is mostly because I'm doing a PhD on that, and I sometimes need to test some stuff and see how people react to that, and I really need some designers' input. Now, C# on the other hand is my own, let's say, favorite kind of workshop right now, as this is really very open-ended, and even with very small amount of information, you can actually take huge leaps when it comes to computational design. So it really gives you a lot of freedom once you even learn some very, very minimal amount of content. And I hope that this workshop will really like kickstart you into coding, because I think it's coding for me. Coding is as essential as reading, which it wasn't always like that for me. It was actually, I learned coding quite late in my life when I was around 27 or something like that. 27, yeah, something like that. So I'm coding for let's say less than 10 years. But then before that, I did Grasshopper, which I count as coding as well. But coding like programming with text, I don't really do that for a long time, but I really do consider it as a critical skill, essentially, especially if you want to do some computational design career. It really, really gives you a big uh, advantage over competition, let's say. Okay, I'm going to disable my camera right now and share the screen. And I've sent, before the course started, I've sent to you, I mean, actually Michael did send it to you, I think, the thing which we're going to focus on first. And before we even start, I will just go step by step and tell you what is each script going to do and why are they in this particular order. And then we'll just go through each one by one and start from scratch. We'll actually discuss the C# component first, how to use the component, and then we'll just go through them. Now we have 4 hours, 4.5 hours, let's say, then we have half an hour Q&A. There is a 15-minute break in the middle somewhere. I also need to drink some water from time to time, so that's what I'm gonna use it for. And then we'll have a Q&A, but as Michael said, like if you have any questions before that, just feel free to ask them on the chat. I'm having two screens here, so one screen is especially for the chat and for any communication here, and then this screen is just to share it. I'll try to have one eye here and one eye here. It's kind of hard.
Might be better to open the Q&A. I think it's better if they ask it there so we can keep track of it. outside of the
Where,
outs-
oh yeah,
outside of the
there's,
chatter.
yeah. So there is a chat and then there is a Q&A. I think that you can use either one or another. I have both of them open side by side. So yeah, so if you are lost, just get it there. Yeah, so the script which you got already and which we're going to discuss just in a second, they are very basic, but in the end, they will give you an understanding of all the key features of C Sharp and object-oriented programming. Plus, if we'll have some more time, we'll try to elaborate on them. So you may, if you had a look at them, you may see that they don't really do much. So they are like very simple scripts, but maybe we'll try to code like no, some kind of component, right? Something which actually does something. Because right now they just illustrate the features of the language, just so that we don't waste time on smoke and mirrors, right? But if we will have time, we'll actually want to use that so that it becomes a bit more of an exercise for you to use it a couple of times, right? The same function, use it a couple of times and it should click, right? So we'll see how it goes. And we have, as I said, we have 4.5 hours, and then some longer Q&A, and I hope that we'll do everything. Yeah, if I'm going too fast, just maybe write it, just to slow down. I'm usually going way too fast, but sometimes when I'm trying to go slower, I'm going way too slow. So I know that it's really hard to be, this Goldilocks problem basically. Okay, so I'm just gonna stop video here and share the screen. And I think this is the screen which I want to share. Yeah. So you should see my screen right now.
Yeah, we see it.
Yeah, that's great. And I just want to open the chat anyway, because it's closed right now automatically. And I have the Q&A and the chat here on the second screen. Okay, so the exercise, there is a bunch of scripts here which we are going to do, and I numbered them from, I think, 1 to 7, and then there is 2 main script which we will try to do. We will try to do at least one, elaborate on it, and then do maybe the second one if we'll have time. So those are like 2 bigger exercises. But the first one here is going to illustrate the value types, so very basic types in C Sharp. Yeah, please tell me if I need to make the letters larger. Okay, I can make this larger if you want. Anyway, so yeah, we'll just see what are the types of data or value types in C Sharp. We'll see what are the reference types, right? So reference types is just another type of object in C Sharp. Then we have collections. So, oh man, this is so irritating. Yeah. So so then we have collections. Collections are essentially bunch of things, right? And we need to know what is what are different collections available in C Sharp. If some of you know Python, it's quite different, right, from Python. So we have what is the next one? Then we have if statements, right? So if, for, and while. This is 2 different things. 3 different things here. Then we have, we have passing objects. So this is something which maybe initially we'll skip, but then we'll go back once we elaborate on the agent script actually. Then we'll want to pass them around maybe, or maybe not. We'll see. What are those 2 scripts showing is 2 different ways of passing objects written in C# scripts between different C# components in Grasshopper, because we'll discuss the component in a second. It's just not as trivial as you think, as it is with just default Grasshopper types, right? It's actually a bit of a challenge to pass, as you see, I have a class agent here. If I want to pass it to another component, it's not really as simple as with default data in Grasshopper. So we have 2 different ways of doing that. One is with, actually using some, one second. One is using reflection. So we will talk about reflection just a second. It's, reflection is scary, but it's actually not really that scary. And then we'll have another method, which is JSON. And JSON is just a very nice way. Then we'll have the first script, which will be about agents. and specifically about the agents. So this is just a random walker. And we already introduced a class agent. We actually try to simplify the code. Maybe here at this point we'll have two separate scripts because this is a very simple agent, right? But I think as we also want to talk about object-oriented programming, maybe this will be a good step where we will illustrate how would the script look without object-oriented programming, right? So there is just two schools of work here, and I think that yeah, some people are totally for object-oriented programming, and I see a lot of people against it because well, sometimes very simple things can get really complex when you do them with proper OOP programming, right? But yeah, I usually try to stick with object-oriented programming. Yeah, we'll talk about what it means in a second as well, right? Exactly. And then we have two scripts. Like one is actually doing the curves which you saw in the promo image. I mean, those are the boxes which are there are just boxes placed along the curves which are traced by the agents. Maybe I can actually enable it here. Yeah, just a second. So this one is, yeah, this is just one script. And then there is another one. So I think we'll start with that one or maybe with that one. We'll see. Yeah, this is the point where I think we'll decide on what exactly to do once I see like how many questions there are, how many of you get confused and so on. We'll just have to dynamically decide what to do next. And yeah, so there is this one, and then there's this one, and then we do the like diffusion limited aggregation. You may know it from Grasshopper forum. So we will do that, but also in a object-oriented programming manner, which is a bit different from what you may know from some scripts in Grasshopper forum, right? Because when you have a script in Grasshopper, uh, when you have a definition in Grasshopper, it usually isn't strictly object-oriented programming, right? Of course, the entire Grasshopper, all the types, uh, yeah, all the types are objects in Grasshopper, but the script which you actually do in Grasshopper is not strictly object-oriented programming, right? So yeah, I see there are some questions about the script files. Yeah, I'm not sure. Okay, so there is the script file which I opened right now. I think this already was answered. The second one. The GH file won't open with the same components. I think you may be missing, or maybe I used a component which is not a standard component, but
No, it works. It's means they didn't read the instructions that come with it that you written.
fine.
It means they didn't put the JSON whatever on the.
Oh yeah, JSON.
Yes.
But don't worry about that. We don't need that for now. We'll do that. Like we'll also learn on the way how to add those like assemblies later on. So if they don't work for you right now, we'll fix it. Anyway, we'll do it. Yeah, I'll just put this definition on the side as a. I have to pick from time to time what exactly was there. And I have another Rhino in here. I think this one. Yeah. And here I'll just create another document. And okay. And in this document, we'll start with the C# component. So there are actually three languages which you can use in Grasshopper. That is Visual Basic, .NET, C# and Python. We are going to do C# because, well, Python is supposed to be easiest, but if you learn C#, you know everything about how Python should work. I mean, it's way easier to learn Python as a second language than as a first language and then learn C#. And when it comes to VB, VB is actually my first language, but to be honest, it's not really that popular. So that's where we're going with C#. C# also, yeah, it's fine. VB is just more Python-like when it comes to the syntax, but yeah. Anyway, I forgot where is the, okay, here is the script, right? So we have the C# script. This is the component here in the maths script C#. As you can see, you have Python and VB. I may show you some VB. I don't know really Python, but if you want, we can then compare the languages if we will have some time, or maybe Q&A. And this component has, as you know, inputs and outputs. I'm assuming everyone knows Grasshopper here. So this is, yeah, I'm just gonna assume that as a ground point, right? So if you don't know Grasshopper, yeah, maybe you can ask some questions, but I'm assuming everybody knows that is a component which has some inputs and the outputs. Now, before, okay, we double click the component, we open the scripting editor, which is far, far away from the nicest, from being a good editor, but it's the one we have. Uh, Before we script anything, let's go back to the component. I just wanted to show you how to open the script. So just double click the C# component and it opens the script. There might be some confusion. Okay, so there is this icon which minimizes it. I don't use it. It just makes it more confusing, like this minimized window. Um, yeah, we will close it. The problem with those is that you can put two editors side by side from the same scripting component, and I don't really know which one is the one which actually goes and injects the code back to the script. So I think there might be some priority here. So yeah, please usually just have one scripting editor open, one script editor open, as yeah, this might cause some problems. Okay, so when we say we have inputs, we can also zoom in, add some more inputs, add some more outputs. We can actually remove this out. It's like a debug output, which tells you what are the problems within the script. So usually you will want to connect a panel here, just to see what is wrong with the script. Of course, you can just hover over this, but it will usually trim the message. So you just want to have a panel here. But if you want to make this, component as a thing which you want to share with other people, and you know that it works, you can actually remove the out, as this usually causes some confusion, right? And this will work as usual. But the problem is that you cannot really add the output. Yeah, we cannot really add the output anymore. We have to do it from here. So we have to reinstate out, right? So reinstate out, and this is like a special parameter in the scripting component, which yeah, it serves as this debug output, right? So we'll see how to write messages to this output just in a second. And this will be very, very useful, right? Because, yeah, you will see. And then we have the inputs and the outputs. Before we talk about what can we do with the inputs and the outputs, we will actually start to code something. So we'll start with that first example when we talk about value types. But just to show you what will be the next step, we'll actually discuss what are those settings, like so the item list tree access, and then the type height, which is probably the most important here, right? So we will see what are the different types which this input can accept. Anyway, let's jump into the script. And yeah, as I said, like we can actually connect the C# script to the panel. Oh, I locked the solver. Okay, so we have to. Okay, I have a problem with connecting that. 1 second. I think there is a bug in this C# component, which is with that reinstate out. Yeah, I think this is causing some bug in the C# component. Let's not do that for let's just do C#. I think there is a bug. This is something which we need to report later on. But yeah, there is a bug. If you remove the out and then reinstate it, it actually yeah, messes up the layout, the component layout, so it doesn't know where the output actually created. Yeah, so we'll do that. So let's start with the value types. Yeah, usually when we say we do something in C#, we'll talk about classes and objects. But there is a special type of object which is called value type. And this value type is introduced so that we don't have to do object-oriented programming with simple scripting, right? Let's say this is a very oversimplified explanation of what it is, but what it means is that we have some basic value types like integers, doubles, text, which when we do them, we don't have to think about all the object-oriented programming in the background, right? But it's there, but it just, let's say, hidden from us. It just simplified so that we don't have to do so much when we do very simple stuff. And what are the value types? Okay, when we want to define a value, we will say what is the type of the value, what is the name of the value, and what the value is, right? So let's start with listing the different types, and I'll just show you how to create those different types of values and what are those different types. So first one will be integer. So integer, and this will be like int. We say int, that's the type of the value which I want to create, and I will say value1, and let's say equal 10. The line in C# has to end with a semicolon. If I type here, this will actually throw an error, right? But at the same time, it's also possible to write it that way, right? The new line character in C# doesn't really matter. We can write that way as well. It's only about readability, right? So we can have those two integers, value1, value2, 10 and 20, right? And yeah, those are integers. What it means, it's essentially negative and positive values with, whole without floating point values. So if I want to do something with those values, I can assign them to the output, right? So this is actually how I started coding in Grasshopper. I just type a equals value1 plus value2, semicolon, right? And it should already start working, right? So when you type value1 plus value2, you press this play button, which is like run script. That is compiling the script. First time you press this button here, it will usually take around, like, no matter what is the script, it will always consume like 300 milliseconds for compilation, right? And then the script itself, when you run it again, takes no time, right? So those 370 milliseconds were just to compile the script. Once it's compiled, you just use it and it takes no time in this case. Okay, so this is how you define two integers, how you output them to the output. What are other data types? Double, right? So when you have double, you can have, I'll just call it val double. I have no good, name for that. So this can actually take some floating point values, right? So 10.5, and we can say that a equals val double, right? And you can see that a is equal to 10.5. Now, you see that I assigned value1 plus value2, so the result of this addition to the a, then I overridden that with val double, and that's totally fine, right? Once you assign something to a, you can always change it, right? I think that you should be able to do something like that even. Not sure. It will probably throw an error. Yeah, it's because of that. But let's say, yeah, let's not overcomplicate it right now. We'll talk about that in a second. But anyway, you can assign different values to the outputs. We have integers, doubles. Those are like the two most common number types. You have different, like double means, why is it called double? It's because it's called double precision, which means it uses 64 bits to store the value. It's not technically a binary value like with integers, so there is some more mathematics behind how to store floating point numbers in memory. But double means double precision. There is also float or single, right? So in Visual Basic it's single. In C# it will be called float. Float is single precision. It will also store 10.5 with more or less the same accuracy, but it's a single precision number, which means it uses 32. So maybe we can combine it 32 bits to store value, right? And this one will use 64 bits, right? And then those are actually 32 bits as well, as far as I remember. Yeah, we have different, like you actually have a lot of different integers which you can use. Those which we're using right now, they are just the default, most common, most widely used when you want to do something very simple and easy, right? Now we have float, then we have, let's say, yeah, we have chars, right? So char, let's say char C is equal to, and here we have to use single quote, right? Today, right? Yeah. So char is just one character, right? So maybe it should be called car, but I think everyone says char. Anyway, so it's character, one character, single character. A bunch of characters is called string, right? So this would be usually called text. And when we say it's a string, we have to use double quotes, right? It can be an empty string just like that. It will work totally fine. If I output that to A, you will see it just says, okay, there's, oh yeah, I'm sorry, this needs a F word, F suffix here. Okay, what is the warning here? I think it just says that it's never used, doesn't matter. Okay, so the component turns orange because there are two warnings from the output, output. It's just assigned and never used. It's only a warning. It doesn't really matter much, right? So when you want to define float, you have to append f. I think small f should work as well to the end of the number, just to indicate that this number is a floating point number, right? It doesn't it doesn't compute automatically the float on the left side to be equal to the float on the right side because it doesn't know what is on the right side. The text is actually understood as numbers in this case, and you have to define that this is this type of number, right? Because if you do it that way, without that, it actually thinks it's a double, right? It assumes by default that the floating point values are doubles, right? So F means that no, it's not a double, it's a float, okay? So single precision. In practice, this will be only like this differentiation, like 64 and 32 bits will be used like, well, where do you actually use single precision values? For instance, Rhino meshes can store, and I think by default they will store vertex positions with floats. Another example is system drawing library, which is used for all the windows which you can see in here, right? Uh, yeah, all the windows which are drawn in Windows, or all the graphics which are drawn on the Windows Windows, right? I mean Windows OS Windows. They will be drawn with floating point values usually, so they will use floats rather than doubles. Why? Because it's not really important to have that much precision when drawing, when on the pixel grid, right? So yeah, there's a question. What's the difference between storing in 32 and 64 bits? Yeah, when it goes to float and double, it's just more precision, right? So let's say if you say 1/9, let's say, right? 1/9, it has to be double, right? So one double. Okay, I will show you in a second why I'm doing what I'm doing, but yeah, one double over one double. Well, this in real life, I mean, actually, this just shows 6 values after the point, but it continues till like, I don't know, like 30 values or something like that with doubles, right? It only prints the first few characters. You can actually, I think we should be able to do. This should print all the characters, right? So this is how many characters it stores, right? So how many floating values after the point it starts. But if we do float, yeah, it's shorter, right? It doesn't have that much precision. So you see, it's not really important in real life, right? Yeah, so it's not really a problem to do everything with floats, but by default we use doubles because it just default right now. We don't have to worry about computer memory so much anymore when we define different values, so it's not really that important. Anyway, I think we need to speed up a bit. So we have floats, chars, strings, yeah, Boolean values. So bool value will be true false, right? So let's say it's a Boolean value. I know. Okay, right. So this is Boolean value, which can be false or true, right? Yeah, Boolean value. Then we can have what else can we have? What are other values which we can have here? 1 second. Yeah, I think I'm just gonna look up for the type kind here. Boolean, ints, double, strings. Yeah, those are the important ones, and I think that's it. Yeah, we can talk about that for hours actually. But anyway, so those are different types of values. Sometimes you will want to convert one value to another value. So there is implicit cast. So the conversion between one type and another is called casting. There are two types of casting in C#: implicit and explicit. Implicit casting is when the compiler figures out on its own how to cast one number, like one type to another number, to another type. Explicit casting is when you say explicitly what do you want to cast the value to. So what do you want to convert it to? And implicit casting will, by default, be lossless, so that if you can, for instance, you can say there is int, let's say we have this double here. So I have this val double, right? But if I say I want to have val int equal to val double, right? You see that I'm asking it to convert val double to val int, right? So it has to cut this 0.5 from the end of the number here. And to do that, it will have to convert it. And you will see that it will actually throw an error because it cannot implicitly convert double to int, right? I have to tell it explicitly that this will be an int. What this will do, it will actually, it will round it, right? So anyway, but I have to do it by placing this int in parentheses in front of the name of the double, right? This could be as well something like that, right? So it doesn't have to be the name, right? But you can see that a equals val int will give you my integer. So you can see the rounding, it just rounds it down in this case. I think 10.6 should round it up, or not really. No, it just takes the whole part without the 0.6, right? So so this is implicit casting. Now we can do the other way around. So if you would want to do double, right? So double, I will just call it val d1, whatever, and you call it val int, right? In this case, it will not require me to specify what the casting prefix, right? It doesn't throw any error here, and I output the val d right now, so I output this, and then I change the a to be val d1, and you see that there is no red sign which warns me that something is wrong, right? So maybe we can just comment all of that. So if you want to comment the entire block, you just do Control E, Control C, right? And yeah, so you can see that converting from double to int is possibly lossy, right? That's why I need to explicitly say that I really want to convert this double to int by placing this int in parentheses. But then if I do the other way around, double to int to double, I know that double will be able to store all the ints possible, right? So it implicitly knows that, well, okay, you are not going to lose any information, so I know that you want to convert it to double. I don't need you to confirm that you really want to do that, right? Because you are not going to lose any information here, right? So we're not losing this 0.8, for instance. So this is like value types. Of course, well, different operators, right? So we can talk about operators, and I'll just show you a couple here. So let's say we have this val d1. If I want to add some value to val d1, I can say val d1 plus 10.5, let's say, right? This is addition, right? So it will change the val d value, val d1 value, and it will, like, you know, this will not have impact on the value, just used as an expression here, right? So it reads the value from val1, adds to 10.5, and then actually writes it to val1, right? So it doesn't matter that it's on both sides of this equation. I can do the same. There is a very neat shortcut, which is something like that, right? So this and this is exactly the same, right? It's understood as exactly the same by the compiler, right? So those two lines are exactly the same for the compiler. Okay. Another, like, what are other ways of adding or maybe subtracting values? We can of course do 10 minus 5, right? Of course, some other multiplication, division here, right? That's quite obvious. Then let me see if I can. I don't really know if this works. No, it's not in. I don't think that this is valid in this language, right? Nah, not really. Anyway, so sometimes in some languages, double asterisk is actually power, but anyway, not here. Anyway, so this is. I think this is everything which we need to know about numbers. Usually they're quite straightforward to work with. Sometimes we'll have some issues like the implicit, explicit casting. That is fine. Okay, let's skip to the next step, which is, let me see on my script list, reference types. Okay, so reference types are a bit different. Let's do an example here. Yeah, see, it's me getting used to VB. Anyway, reference types. So we have, as we saw, those were value types, and this is just a special case object. Everything in C# is essentially an object, but if you have this double, let's say value, right, value, and you say, oh, it cannot, value is a keyword, so it has to be val, right? If you say that, maybe we can have double val2 will be equal to val, right? Now, what do you think will happen when we do that? Okay. Okay. Will this add 10 to val2, or will it also add it to val, right? With value types, it will actually add it only to val2, right? So that is really important, that the value which you're actually using in the script, right? You can see that this is 20 and this is actually still 10, right? If you do that, what it does, it essentially copies that value, val, in here, and then it creates a copy of that to assign it to val2. Those two are completely separate entities. That's just value type, right? But in memory, they are actually completely separate entities. Whenever you call the val or value2, it will usually bring a copy of it, right? It will not really, it will always create a copy of that value. So with reference types, which are actually most objects in C# which you will ever encounter in any programming, will be usually classes, which are reference types. They work a bit differently. So let's say we can have Rhino, geometry, mesh or a circle. No, circle is a struct, so maybe we can have a mesh. Let's create the mesh. So we have a mesh. Okay, so when we talk about classes, classes will usually have a very special way of creating classes. So instantiating a new class is always done with a function called constructor. It's a special type of function. This constructor is indicated by the new keyword. So the new keyword is indicating that from that point on, this new thing is going to be a new thing in memory, right? So we can say, if you want to create a new mesh from scratch, this is how you do that. You say that you want to use Rhino geometry mesh. We actually can skip that. It just can be mesh. So it's a mesh. Uppercase, lowercase is preserved, right? So Visual Basic doesn't distinguish between, will not distinguish between lower and uppercase. C# does. So mesh is a type of the value which we want to create. Mesh here is lowercase, is the name of the thing which we want to create. New indicates that we want to create a new one, and the mesh with empty parentheses is what is the constructor which we are using. There can be different constructors for the same class. So we can say, I don't know, maybe it's a mesh and it has some parameter in the constructor, like 10 by 10. It might be a mesh plane with 10 by 10 faces. It needs then 2 arguments in the constructor. They will be provided to the constructor in that way. But with no arguments, we are just using plain blank mesh. So we can start from that point. Now, what can we do about this one? Let's say, okay, let's create some mesh, right? So let's get some vertices. So I will type mesh vertices add, and yeah, if you have different ways of adding vertices, and I'll create the one with 3 doubles. So I'll create a simple mesh square, right? So that way. So you can see I'm just typing the coordinates by hand for the 4 points. Maybe I can show you my screen and just show you what I want to do. And I hope, I mean, for those of you who know Grasshopper, this should be quite obvious what we're trying to do, right? We have 4 vertices, so 0, 0, 0, 1, 1, 0, 1, 1, 0, 1. Those are the 4 vertices. They will be here. And now I need to add a mesh face to it, right? So mesh also has faces, so mesh faces add face, and I'll just type the vertex indices by hand, and I'll say that a output is equal to mesh. Okay. So now I have this mesh in the output here. Okay. So this is a mesh in the output. Now, yeah, if you want to duplicate lines really fast, you can just Ctrl+C, Ctrl+V, right? So without selecting, just Ctrl+C without selecting any text, and Ctrl+V multiple times. You can just put it that way, or just put it here. Okay. Okay, so we have the mesh at face, this mesh. And now, just to show you what is the difference between value types and objects and the reference types, we'll create another mesh. This mesh will be called M2, very original, right? And it will be equal to mesh. Now, if I want to move a mesh, I'll use some translation, right? But just a second. But right now, if it was a value type, M2 would be a completely separate mesh from the initial mesh, right? Just like here, right? This exactly here. But because it's a reference type, what we're getting here is not really the object itself, it's actually the address of memory which it occupies in the RAM, right? Not really necessary to know that reference type will just not work with the actual data, it will work with the addresses of the data in memory. So you pass only address here, right? So this line passes the mesh address to M2, right? So this is nothing more than passing the address in memory. You can actually, like with some more coding, you can actually know exactly what bytes in memory, which number of, bytes have different numbers, which byte, which address exactly this mesh is stored in, or this the beginning of the mesh, right? Because it usually takes more space than 1 byte. But yeah, this is now what it means is that if I do mesh transform or translate, maybe let's use simpler one. So mesh translate 001, right? Or maybe M2. Let's say M2 translate. Yeah. So we have M2 translate. Now what it means is that it will move it up like by 1, right? But you can see that I'm outputting a mesh, right? Right, it's the same thing. Mesh and M2 are exactly the same thing. They just have different names. In this context, they just have 2 different names, but essentially they are exactly the same thing in memory. And this is quite crucial because if you were to create a duplicate, well, usually you will have to create this class from scratch, right? So in Rhino, almost all the geometry classes, or all of them, will have a function which is called duplicate, right? So this function, I think we have to call duplicate mesh, okay? So this function actually assigns a duplicate of this mesh to M2, right? And then when I translate the M2 and output the mesh, I see the original mesh. And when I put M2, I see the M2, right? So the one which actually got moved. But you really need to have the duplicate mesh because it creates a completely separate copy of this mesh in the memory. I will leave it like that because it's a bit better. But yeah, this is the key here, right? So here when we assigned val to val2 and then we added val2, val remained unchanged, right? But here when I assigned mesh to M2, transform the M2, it actually transformed the mesh as well, right? So this is the difference between value types and reference types, right? Reference because it's just a reference, right? The type is the thing which we operate with is just a reference, so it's like an address, right? It's actually essentially an address, right? Just the address of the object in memory, right? So this is very important to understand this differentiation because in the beginning, when you start to code, this will cause you a lot of troubles. And you always have to ask yourself whether you operate on the right thing and not on a copy of it, or not on the thing which you thought it's a copy, but you actually destroy it somehow, right? So this is, yeah. Okay, so I see I heard the exact same script, but I didn't see the geometry. Maybe you have to output the geometry here, or maybe disable the preview of the component. That might be a reason. And then there's value types stored in stack and reference types in heap memory. I remember reading about that, but I didn't really remember how it works. I think that this is in C#. I think everything will be stored on heap, and the stack will not be accessible. But don't quote me on that. I'm not really that much into memory management there. My background is not C++. I mean, if it was, I would probably know the right answer. But you can certainly take a look at maybe later on. Okay, I think I know exactly where on the MSDN website is the answer to the question. Maybe I can just add a link to that, right? So when the stack and heap memory allocation, it's on the MSDN website. But anyway. Yeah, so just because of that stack and heap thing, I think that C# is supposed to be slower than other languages where you can explicitly say when you want to store the variables, right? But yeah, it's kind of automatic here. Anyway, we have this. Now let me see the other script because I don't want to miss anything. Oh yeah, collections. So collections and F4. We have 1 hour. Okay, I'm just trying to plan ahead. So I think we already run for like 45 minutes and we did those two. Now another 45 minutes for collections if and whiles. And then we'll try to do some objects with random walker. That will take like an hour. And then after that, we'll have like 2 hours for it for, well, either one or both of those scripts. We'll see. Yeah, so let's do collections. Maybe we can couple them together. Uh, so I'll do another C. Maybe let me save this file. Just if anything breaks, I don't want to have a copy. So C# again. Collections. Okay, so collections. There's a lot of different connections in C#. You can write your own collection type if you really want to, but all of them, well, almost all of them end up as an array, right? So somewhere in most of those collections, in the background, there will be always some kind of array, right? So you have we can have arrays, and then the second collection, which is like second most popular collection, or actually I would say it's even more popular than arrays because it's a bit more convenient, is a list, right? So we have lists, arrays. Of course, there is more collections. There is sorted lists, dictionaries. There is well, observable collections, so collections which are actually thread safe. So there is there is literally hundreds of, like, maybe not hundreds, but at least dozens of different collections. But what you really want to know is the list and the array, right? Those are like the two classic ones. So let's start with array. Let's say that we have let's do some point array and a list array, so we can maybe get some geometry in here. So point 3D array. So that's how I define an array type, right? I say what I want to store in the array, and then the square bracket is actually telling it's an array of 3D points, right? Point 3D is a type from Rhino geometry, right? Yeah. So point 3D is a type in Rhino geometry, so that's how it knows what it is, right? Let's call it PTS, and I'll say new point 3D, and here in this square bracket, I need to say how many points I want to store. So I'll say 10, and then if I say A equals PTS, I will have 10 values here, right? Okay, so I have 10 values in this output. Now you can see that all of them are actually 0, 0, 0. That's because that's because the default value for a point is 0, 0, 0. Now, we missed, because we talked about the value types and classes. There is also a way to couple a bunch of value types together to create a struct, and struct behaves more or less like a value type. So point 3D is actually a struct. If you type Rhino geometry point 3D, you can see this symbol here with those two dots. This symbol stands for a struct. So it's a structure. What it means is essentially it's not just a single number, it's more than a single number. It's sort of a class, but it really behaves like a value type, right? So when you call the point, you actually get a copy of it, right? Let's say. I will also, like, I know that it's super confusing right now. I completely understand, because I remember, like, it took me like half a year to figure out exactly the differences. But as we go with the code, I will always accentuate where exactly we use the struct, where exactly we use the classes and the value types, and why does it work in that way and not the other way. So right now we have an array of structs, which, consider value type, right? And let's say I want to create another collection of points, which will be a list. So list, the syntax to create a list is just a bit different, right? So that's what I want to show you. Array has a very specific syntax with that square bracket. It's a complete different for list, because list is yeah. So you'll find it frustrating that this script editor really changes this type. Like once you press the space bar and you still have the IntelliSense, that window popping up, we call it IntelliSense, right? And if you have that window and then press the space, it actually converts it to light. So what you need to do, you have to press the escape button when this window appears, and then press the space bar. It's a known bug. It's just this editor. So we call this list of points as, I don't know, I'll just call it list. A new list of points 3D. Escape, close the, I mean, it's not a square bracket, it's a triangle bracket, right? And let's just focus for a second on this line exactly, because array is just a specific syntax. We don't really worry about the syntax because once you learn it, you know it. But here, this is a syntax for objects, right? So all the objects will have, all the classes will have similar syntax, but what is special about the list is that you have to define what exactly they want to store in that list. So in this case, we want to store points, and I use the triangle bracket. Yeah, a triangle bracket to define what exactly do I want to store in that list. It doesn't matter what it really is. Like you can store anything. You can store a value type, a reference type, or another struct, or another list. You can actually do a list of lists, right? Just like that. And another type in that list. But we always define it list of points, right? We say that this is a list of point 3D. So that's how you say, how you describe the syntax to another person. Like it's a list of points. It's a named list, and there is a new list of point 3D. And we have to do that around, I mean, the parentheses. We have to put the parentheses because what we use in this case is the default empty constructor. Empty constructor means no arguments in the constructor, right? So a new list of points. But again, I need to specify what I'm going to store in that list, right? You cannot do something like that, right? This will actually throw an error, right? Yeah. Again, it's actually implicit casting error again. So yeah, you cannot convert one to another. Okay. Now this feature of language where it actually really cares about the types is called strong typing, and this is a very good feature of C#. Contrary to Python, when it's loosely typed, Python dynamically will adjust the type of the value to just to make the code run, right? C# is much more picky about the types, right? It has to really, like, all the types have to match together, and there is some implicit casting, but it only works with very simple types. Or yeah, we will talk about inheritance later on, so maybe we'll talk about that again. And again, if I want to add those points to the list, okay, if I output that list, it's just an empty list, right? So there is nothing here, right? Okay, you can see nothing in here. So if I want to add anything on that list, I will call add. Yeah, mind the capital letter here, right? So this is really important. Add. And now I have to create something what I want to add on the list. So typically, okay, so with no syntax, features, like with very simple language, you would usually define the point here, right? So we will say that this is a new point, 3D. Notice it's a struct, but the constructor is the same as if it was a class, right? But it behaves like a value type, as we already discussed it. So you can say one, right? So we can say list at pt, play, and you can see the list in the output has one point with those 3 coordinates. Now, because C# is quite an advanced high-level language, what we can do, we can actually do that. We can delete that, put it here, And now we have this compound statement here. It does exactly the same as we did a second ago, but you don't define this local variable pt. You just define the point and right away put it on the list. Okay, so this is quite neat about language. Note that the script editor in Grasshopper is using, I think it's C#5. Currently, we have version 9, I think, or 8. And there's a lot of features in syntax which are really getting better and better. So yeah, C# is now way more advanced than even in this editor, but we are not going to use those features anyway. But when you code, like professionally, when you code and you want to code really efficiently, like new C# editions have really great features which it speeds up your work by factor of 2 or 10, something like that. Okay, I can see Michael appears on the screen. Is there any question? Okay, I think there is. Can you hear me well? I mean, yeah, okay, that's fine. Yeah, because I saw Michael on the screen. I thought that maybe something is wrong. But okay.
Hey, sorry about that. No, my internet dropped for a second. I was just making sure that the webinar didn't go away.
No, we are here.
Okay. I wonder, can you just repeat the past 5 minutes?
Repeat. Oh, because of the recording. Yes.
Yeah,
So
I just don't know how it works. If like I drop out, does it still keep recording? I don't know. Never happened to me before.
oh yeah, I think it should still work. But anyway, what was the last thing would you have?
Just like 5 minutes.
But after the array or before the array?
Like a little bit before.
Okay, so maybe I can just describe what we have here on the screen. So we have the two different syntaxes here, right? One syntax is to define the array, and it's a very special syntax again, because you will not see exactly the same syntax in any other collection type, right? Or maybe, yeah, I can't think of any right now. So it has this square bracket, right? And the name, and you say, what do you want to store in the array? Square bracket says that it's an array, the name of the array, and then how many of those things you want to store is the number in here. Now, the second syntax is with the list. So this is another collection type. You have the list. You have to define what is the value, what you want to store in the list with that triangular bracket here. You have the name of the list and you say that it's a new list of that type. You have to define what is the type. And then we are using empty parentheses here just to say that it's a default constructor, right? So new keyword indicates we are using a constructor to create that list. Empty parentheses says that there is nothing to pass to the constructor. So usually it means it's an empty constructor. We call it an empty constructor, but actually behind the line, like under the hood, it can do quite a lot of different things. It's just that from our point of view, it doesn't really require us to specify anything else. Now, as we said, we have a way to add, so we can put the point, if we want to add stuff on the list, we can say point3dpt equal to new point with coordinates. We can add it that way, but we can also add it with, maybe we can change it a bit, with that syntax, right? So you don't have to specify this local variable here, this pt, to actually add a point on the list. You can just specify it in this single line. And now when you see here, I have actually two different points. That's more or less what we talked about so far. So this is just to get you familiar with the syntax, but also what are the differences between those two collections, and this is quite important. Like array is fixed size. What it means is you cannot add more values to the array. When you have 10 values and you output the PTS, there is no way to add more values. So if you say PTS, there is not really any function or method to change the size, right? It says it's fixed size, but I think it's for I'm not sure what is that for, but anyway, Yeah, technically, I think there are some methods to add more values to the array, but what they essentially do, they copy the array to a new array, which is a bigger one, right? So they copy the values from one array to another, essentially. So this is quite cheating. Uh, okay. Yeah, there is a question. Is an array similar to a tuple? I think a tuple in Python is just a key value pair, and this is a special, I think it's called key value. I'm not sure. Yeah, it probably has to be, or actually we can say tuple here like that. This will be even closer to the Python one, right? But I think we need to import some library to use that. Anyway, yeah, those are both essentially collections. So maybe a tuple is usually, as far as I remember, in Python, it's exactly the same. So a tuple is a collection of numbers, but there can be two of them, three of them, four of them, and so on. But if you want to use 100, it's kind of inconvenient. In C#, tuples are supported up to 6 values, I think. But in the end, when you work with tuples, you work with single items, which may have like two or more, three more numbers, but you consider this collection of numbers a single value, right? When here we have an array which possibly have millions of values, right? And now list, on the other hand, is a dynamic collection, right? So we say that PTS is, I mean, static is a wrong keyword, like it's a word, it's a wrong word here. But static is, I mean, I'm sorry, array is fixed in size. List can be dynamic. Now, to be honest, list essentially is an array which resizes itself automatically when you operate, when you add more values, right? So when you add more values to the list, the array which is under the hood of the list is just being copied over and over to larger arrays, right? So it's still an array, but with some nice features. So you can have list add, and you don't have to worry how many things you have, right? You can add as many points as you want, and you don't have. I mean, there is some limit, but it's far away. So if you want to add more stuff on the list, you do it that way. If you want to, let's say, if I have a list which looks like that, so it's just reversed. I could reverse it as well, right? If the type which we store in the list has a way to sort or compare to another instance of the same type, we can use list sort. Most types do have it, right? So if I do list sort, you will see that the points will get sorted, right? So that is, yeah, that sorting is, if you will have, for instance, what is the type? Like if you have a custom class, okay, let's say if you have a custom class which you write on your own, you put it on the list and call sort, it will do nothing, right? You have to implement IComparable, I think IComparable interface on the class to make it sortable. Yeah, I think it's IComparable. So so in other words, you have to tell the list how to sort your values. So we have to have a method which does that. Anyway, so the list sort, of course, list add, but you can also do list remove add, and you can say remove the first item, right? So it's not so easy with array, right? With array, you can assign different values there, right? So we can say that PTS 0 equals to list 0, right? Notice the square bracket here. It's the same for the array and for the list. So that's actually quite, yeah, I mean, the brackets and different parentheses were actually the reason why I chose Visual Basic first, as my first language. I just couldn't stand that many types of parentheses and brackets. But in the end, I mean, they kind of work once you know how to code in C#. So yeah, you can see that if I want to assign, I have this array of 10 points. I assign the first from the list to the first on the PTS, and I output the PS, it's actually that, right? So if we say, now again, point is the struct. So what it means is if I say list 0x is equal 10, I'm sorry, can we define the return values? Whoops. I think there is a here. I don't think it works that way. I think it's 1 second. It's not a variable. Anyway, we can do something like that. Let's do like that. Yeah, so what do you expect from that, right? I mean, if I change it that way, if the point was a class and not a struct, this would actually change this coordinate here, right? But because it's a struct, it behaves like a value type. So when I call it that way, like I say, I want the first value from the list, and I want to change the x coordinate of it to 10, it will not change it. It will create a copy of this point for the P0, and then this only affects the P0. You can actually take a look at the list. It will also not change the value of the list, right? So this is the difference between value types, reference types, essentially. Yeah. So yeah, when you see a class, so when you have a class, let's say Rhino geometry mesh, you can see this icon here, this small here one. This stands for a class, but when you say a circle, this one with 2 dots is actually struct. Struct will work like a point, and classes will work just like mesh. Right? So we did before the mesh example, it worked differently. So we have the we have the another example here, and now let's go with what should we do right now? Yeah, we should do if, while, or maybe not really while. We don't really need while, but we need if and for. Okay, and so we'll merge it with the collections. Let's say another C# script. And here we have, maybe I can output panel here. Okay, I just want to disable the preview of everything but that one component here. Okay, so what I want to do now, I want to create a simple, very simple for loop. Okay, so for loop syntax is the worst syntax of all the syntaxes in C#. That's why you have a double tap trick, which is if you type for and press tab twice, or actually once, depends on the editor. But if you type for and press tab once, you will have that snippet inserted automatically. And this is really useful because you can see the syntax for the loop is quite strange, right? I think both for Python and Visual Basic, the syntax will be something like for 0 to 10, right? Something like that. This will work for, yeah, I think Python, or maybe, anyway, for all the normal languages. But C# has this very strange syntax. Oh yeah, there is a question. How would you change a struct member in a list? You will create this copy like we did the P0 and then assign it back to the list. So like we had the list value, the list 0 will equal to P0, right? So this is how you have to assign it back to that value. Okay. So this is how we change it. I think we'll do it anyway. So this is the syntax now. Yeah, so we have the for loop, we have, the for loop, for I, and length. So length is, okay, so let's discuss the syntax. So in the for loop, okay, so there is like the simplest loop which you can create in C Sharp. I think it's either do or while, which means run this code in the brackets, in the curly brackets, until I tell you to exit the bracket. But to simplify, I mean, it's really easy to crash your laptop with that. That's why they invented the for loop. For loop is just a more complicated loop where you have a value I, right? Or you can change the name of the value, but you have some value. We will call it a counter, and you run the loop unless until the statement in the value declaration in the for loop declaration is true. So what you can see here is we have value int I, that's the counter. In the beginning, it will be equal to 0. We'll run the loop for as long as I is smaller than some length. We have to define this length in a second. And this syntax, I++, it means that for every time you run the loop, you increment the value of I by 1. Okay. If you were to increment it by 2, you could say 1, something like that, right? Or like that, that's for 1, right? But I++, that's incremented by 1. I think you can increment it by 2 by putting 4 plus signs, but I'm not sure. Anyway, so we have we have this loop. Now we have to define how many loops we want to have. Notice that I is 0. So if I want to have, if I want to run that code in those brackets here 10 times, I will say that the length is 10. So I say it's 10. And let's say I want to create a list of points. So I'll take a list of points 3D. PTS again. New list point 3D. Okay, just like we did before. And now in this loop, what I want to do, I want to create a single line where I add a point. And I will add a point which will be 0, I, and 0. Okay. Now output this list of points here. Yeah, we'll have a short break. I think there's a short break planned in half an hour, but maybe we can make it sooner because I think that it's, yeah, that's a question too. We have like a 15-minute break planned, which is considered a longer break. But maybe we can have like a 5-minute break right now. Is it okay? Yeah, okay. Okay, so maybe let's have like a 5-minute break till 5 past 5, and then maybe the longer break, maybe we can shift it a bit further down the line, right? So let's meet at this is my time block, all right? So something like that. Okay, I'll just mute myself and then we just meet in 5 minutes. Okay, so we can continue now. I'm just looking. Yeah, there was a question about stack and heap, and I just wanted to look for that, but uh, yeah, I think it's not as simple as I thought. But I think yeah, there's like a really long explanation of that. But anyway, we can discuss it after the class. I think. Anyway, so yeah, so the syntax for the loop. Yeah. So the syntax for the loop is quite complex, right? But with that, for and tap, this just inserts it, and this works with almost all like code editors, right? So you don't have to really worry about that syntax. It's good to know what it means, right? Because we will always want to change it somehow. But yeah, note that this int can be a double as well, right? So you can define it as a double. Right? Doesn't really matter at all. And then this I could be something like that, right? So it could increment with 0.5, and then we have more points, right? Because we use those points. But I'm not going to use that. I'm just going to use the 4i with 10, just to keep it simple, right? But essentially what it does, it runs this code in the brackets as long as this statement is true, right? So this is fine. Uh, yeah, so this statement, oh, maybe this means that I is smaller than 10, right? So increment I until I is smaller than 10. When it's 10, it's actually not running this loop anymore. So this is the thing which we wanted to talk about, the for loops. Now, another thing which I would like to do syntax-wise, because then we are going to talk about objects and we'll create the agent and the random walker, talk about maybe inheritance, we'll see. Another one is if, right? So again, if tap will put the syntax is much easier, but what it means is that this code in the brackets will run only if the statement in the parentheses is true. So by default, it puts true, right? But we don't really want to leave it just true because it will run always, right? We want to have a sort of a switch, right, which tells us whether to run this code or not. And this switch for me will be if I is even or odd, right? So how to check if I is even or odd? That's a classic example. Like if you had any scripting classes ever, I think that this is something which the tutors always show because it just introduces another operator, right? So if I is okay, so this percent sign stands for modulo, right? So what it means is that if the rest of division I over 2 is 0, then it will add the point, right? Okay, so modulo, we can also say that maybe I can just write here. So 10 modulo 2 is 0, right? Because 10 divided by 2 is 5. There is no leftover, right? But if I say 10 modulo 3 is actually 1 because 3 plus 3 plus 3, that's 9. And there is 1 left and we cannot divide it by 3 with integers, right? So the rest is 1. So 10 modulo 3 is 1. And 10 modulo 2, or just a number modulo 2 is a quick way to define to say whether a number is even or odd. If the rest of the division is 0, it's odd. Now else, so this is the rest of the syntax, let's say. So in other case, I will add a point maybe with different coordinates. Okay, So if I is even, then put the point with x coordinate equal to 0. If is odd, put the point with x coordinate equal to 1, right? And we have the zigzag pattern, right? So I know it's very simple right now, but we'll get there, right? We need to understand all the pieces which we'll use to actually define a class in a second. So this is what we have. For if then we have, yeah, that's that. I think that's it. So the next thing which I would like to do is to get yeah, because we want to make this random walker. So maybe let's take a look at how it is supposed to look. Yeah, let's take a look at how it looks. Right. So so this random walker is just the simplest agent you can imagine. It just takes a random step in a direction, right? And here we actually have this is object-oriented programming, so we actually have a class called agent, and we use the features of this class to perform this, this action. You could imagine this as just adding points on the list, but that's not the point of this exercise, right? The point is to actually define a class. We'll add this agent with the random movement, then we'll copy paste the script and elaborate more on that with fields, and we'll try to create this pattern which we have on the poster image. Okay, so this is, we'll use exactly the same code here, we'll change the code here, and then if we will have some time, I'll just show you how to animate it. If we will not have time, I will send it to you after the workshop, right, after the webinar. It's, yeah, it's a bit tricky. So I hope we will have enough time, but yeah, I also don't want to go too fast because, yeah, going too fast is worse than going too slow. So we have this, and let's get, yeah, before we get to actually create a class, let's create our own method or a function. In C#, everything is called a method. In Visual Basic, you distinct between methods and functions. Essentially, it's the same, but one returns a value and the other one just runs some code and doesn't give you anything in return. But in C#, it's all called my method. But I will say method or a function, it doesn't really make much difference. Before we add yeah, there is a question, will we discuss the Rhino common? Yes, we will, and we will see the documentation and how to get this code to work, of course. I think that will be done with the agent. Maybe we can, yeah, I'll try to get the documentation somewhere on the screen. So we have the, yeah, before we go any further, I just want to show you what is happening in the script component. So you can see that if you put all those plus signs here, right? Just to take a just to see the bigger picture, what we've been doing so far is in the run script, right? And this run script, you can see that it has object X and object Y and ref object A defined. So object X is X input, Y input, and A is a reference to an object A, right? So object A is just the A output. But what we've been doing so far is just one function, one method. Void means that it doesn't really return anything, right? Because it just runs the code. Now, this entire script is actually a class, one instance of a class. So what we've been writing so far is a function or a method, a void, in a script instance which inherits from Grasshopper script instance. That means that it inherits, right? So we'll talk about inheritance if we will have time, but inheritance means that there is another class which is called G8 script instance, which has some code in it. Inheriting means that I want to copy that code and add some more code to it. So script instance essentially copies all the code which is in the G8 script instance and adds the code which you can see here, okay? That is nothing like, this is inheritance 101. This is all you need to know about inheritance. Inheritance is basically adding some code from some other class and adding some more to it, right? Subscript instance is just a class, as I said. It has different like stuff here, members, functions. we are writing so far run script, but in here you actually have the custom additional code. And in the custom additional code, we can actually write our own functions which will exist in that script. Okay, so let's now maybe get this code and let's create a function out of it. And then let's use this function in the run script. Okay, so what our code has is it produces a list of points. So it will return a list of points, right? So we have to, anyway, we have to say it's public, right? Public means that this code can be accessed from, in the context of the script, it doesn't really make sense. But in the context of some bigger libraries, public means that it will be visible for other people which are using the library, right? So public, and now we write what is the return type, so list of points 3D, right? So we will say that this method is public, so visible to anyone, will return a list of points. We'll name it produce points, or maybe, yeah, let's say zigzag, right? Whatever, zigzag, right? So that's the name of the function, right? Then we have to say, what are the inputs for this function? And I would like to change the input, which is the number of points. So I'll say it's an integer, which is called count. Okay, I'll just count. And then in curly brackets, we'll define this code. So we'll essentially take this entire code which we wrote so far in this script. Okay, we'll put it here, copy paste. And now we don't have the A. Notice that A was defined in the run script as one of the parameters in the call, right? But here we don't have the A anymore. So this void and this list, this void, this run script, and our zigzag are equal, right? They are standing next to each other, right? So what it means is that whatever we write in one is only visible to this one function. It's not visible to other functions. So I cannot access A from another function, right? I have to, if I would like to get to use this A in here, I would have to have an input here, which will pass this A to the zigzag function. So this is like contexts in C#, basically. Whatever you have in the curly brackets is only visible in the curly brackets. We cannot use A, but we say that our function returns a list of points, so we simply return, right? So I will write return points. And now the count is here. Instead of 10, I'll use count. Okay, that's all I need to change. And now when I say A equal count, I have to say how many points I want to create. So I'll say 3. And we have a problem. Oh, I'm sorry, it's zigzag. Zigzag, right? So zigzag 3, and that produces 3 points. So like that. Yeah, so you can see that this is how to create a function, right? Within some existing class. So the class which we're writing within is the script, right? But this is just a function. Now, yeah, we'll do the agent now, agent class, which will be a class within a class. So right now we are creating a method inside another class, but we can actually define another class in a class, right? Which is called a nested class sometimes. But anyway, it will be only visible. I mean, not really. I mean, it depends how you define it. It depends on the context. It can be visible to some stuff outside of the class, but that doesn't really matter right now. Yeah, so you can see that this is how you define a method. If you don't want to return anything, right? So maybe you would like to just create some code which does something, right? So maybe reverse list, right? And you have a list of points, 3D points, right? You can do something like that, and it doesn't need to. It doesn't need to return anything. Void means that we don't expect it to give us anything, right? So we assign the zigzag output to A. That's why we have three values in the output, right? We assign those points to the output. But if I call Mm, yeah, if I do that, like I don't know why, but anyway, if I do that, it will not produce any value. It will be nothing, right? I think it will actually throw an error, but I'm not sure. Anyway, so we have void, which in VB will be called method, and this where we say what is in the output as a list of points here. This will be called a function, but we can call it also a method if you really want to. Yeah, so yeah, there is a question, do we have class from a library or we define it? No, we will actually create our own class, but I will also try to show you how to you define your own, I mean, how to get some classes from other libraries. So that's, yeah. Okay, so this is how you create your own methods. You have the for loop, if statements, we don't worry about the while anymore. Like, I mean, it's not really that important. It's just another type of loop. For loop is the most common, let's say, right? 99% of loops written out there is for loops. So for if methods. Now we go with classes, right? So let's create a class. Oh, maybe one more thing because before we do that, because we will eventually, like with the next exercise, we kind of enter the second part of the webinar. So maybe let's before we do that, let's try to do some more basics. We didn't discuss the components so far that much. We just said that we want to, like, if we want, we can add more inputs. But if we say that I want to have a slider and pass the value of the slider to the function zigzag, you will see that it will throw an error, right? Okay, so what is the problem is that you can see in this function, in this declaration here, that the x is actually defined as object. So the zigzag requires us to provide it with an int. Okay, and to do that, we need to change the object to int, integer. And to do that, you right click the x, say type height, int. Okay. And now you can change the value of like the x value with a slider, right? Now, if you want this input to be a list of ints, right? So let's do that for the y. You can, yes, you can say it's a list, and then it's an int, right? So we can say that y now became a list of ints. Okay, I hope that by now you kind of start to like put all of those pieces together, and I don't really have to tell you what exactly it means, right? Because we already had lists of points. Now this is a list of int, and if you put a list of numbers in y input, you will actually have access to all of them in the script, right? From here. Now int x is passed here. There are different types. So, oh, and the tree access is a data tree, but this is, I mean, we don't really want to go there in this webinar. Data tree is just a different collection type. It's the default collection type for Grasshopper, but it's very super Grasshopper specific. So we don't want to do that. It's nowhere like you will not find any software other than Grasshopper that uses data tree. Not really that useful, right? At least for us at this point. So we have a C# script, and now we will create an agent class. This agent will, well, first of all, we'll just define a class, and then we'll see what actually do we want to get in the input for the component to let the agent run. But yeah, let's see. Okay, so we want to create another class in this component, and we do this in custom additional code, right? So we'll say that this class will be called agent, and we also want to make it public just because, yeah, I mean, it's not like we're gonna use it anywhere else, but I mean, I have this habit of just declaring it public because of Visual Basic. In Visual Basic, the default accessor, this public thing is called accessor. The default accessor is actually, access modifier is actually public, right? But in C# it's private, which is the opposite as far as I remember. So we say it's public. Now it's public class, right? And we call it agent. Now we don't do rounds, like we don't do parentheses here because it's not a function. It doesn't need the input parameters. We just say what is the recipe for the agent. So we just do something like that, right? Now let's say that our agent will have a couple of properties, okay? And now the properties are, yeah, this is, so when we have a point 3D, let's see how property usually looks. So when I have a point 3D, PT, new point 3D, when I put dots, I can see X. And you can see that key here, that's actually a property icon, right? So I know that X is a property of point 3D, okay? So I want this agent to have also some properties. The two properties, I think, let's start with one. Let's go with public property. So public, we say public point 3D location, and this is the property. When you set the get, when you put the get and set, sorry, I think this we need that. Yeah, when you put this get and set in a curly bracket, this defines the location as a property. Now, why do you want to do it that way? Okay, so let's discuss another case. Point 3D point. Okay, then we have to do that. I know. I just want to show you the difference between functions or methods and properties. So when you have the agent, one second, you see that there is a difference between location and a point. Now, why do we have this difference? I mean, there is some features which are different, and there is some, let's say, readability issue, right? So the functionality first. When you have a property, when you get the property from an agent, you can return something, right? So you can actually get some value here, right? So val. And val can be somewhere defined as public double or private double even, right? Right, so this can be like, this can be defined something like that, right? This gives you more flexibility in what you want to get compared to how you want to set the point, okay? Also, you can say that set will also, like, you can have a function to get a point and function to set a point, okay? But we will only focus on that case which we have right now, which is get and set. By default, this does the same. When you set some value to it, it will assign it to location. When you get, it will give you the location, right? But you can define different ways of getting and setting the location here. And this is just flexibility, right? So this is one functionality. Another is that you can say that you want other people to see what is the location, but you don't want them to change it. So you will say the set is private, right? So this is quite common to see that because, you know, sometimes you want other person to see what happens with a value, but you don't want this person to mess with the value because it will break the code somewhere. Again, we are not going to do that. Now, when you have a function, notice that the function will just return a value, but you don't have a way to change this point, right? Like you don't store it anywhere. You just create it here, right? You could, I mean, you could do like a private point 3D. One second. You could do that, right? But let's discuss what it will give us, right? So you could do return PT, but then you would have to have another function which changes that point because it's not public, right? It's called private. It's private. So to simplify all of that, the C# just has this syntax of a property where you have the get and set. It's called getter and setter functions, right? So This is what you have. Now, let's see if that works. Yeah. So if you don't define the constructor, you can still construct the new agent by saying new agent with empty mm, parentheses. But you can actually do your own constructor, right? So if you want, this is a property. So let's say property. Now this will be constructor. So constructor. And in this constructor, maybe we want to simplify coding with agents. So I will say public. So this is a public constructor, public agent. And here I will say point3D location. Notice the small cap, right? And I'll say that this is a keyword which I can use whenever I operate in the class, right? I can always say this. So this instance of the class location will be equal to location, okay? Oh yeah, and now when you define this constructor with one argument, you actually have to have another constructor which has no arguments. So when you don't have any constructors, it seems that it's accepted the empty one, but here it's once you specify a constructor with an argument, you also have to say that it's possible to construct it with no argument. So this is empty, and this one parameter constructor. Okay. Yeah. So this is how we define our own object, essentially, right? The class is an object, right? And that's why we call it object-oriented programming, because most of the code which we want to write is not really in the methods, right? We're like in this run script, what we did so far. We want to do everything in the agent, like, or do as much as we can in the agent. So when I want to move the agent, don't want to manually change the location of the agent. I want to have a method in the agent which is called move, and then it accepts a parameter of the translation vector, for instance, right? So let's do that. So let's say method one, moving the agent. Okay, and this will be a public void move, and here we say vector 3D vector. Okay, and what it will do, it will take this location, right? So it takes the instance of the agent and location, and to this location it will add a vector. I mean, let's do it that way. So this location plus vector. Okay. Okay. So this works. So nothing really fancy here, right? If I move this agent by some vector, you will see that the point just changes the location. Now, to make it visible to you what actually gives it to us, let's create a list of points so that we will always have the entire history of all the movements, right? So let's create a public list of points as a property, right? So we will call it the history. And this will be called, yeah, get and set. Now the problem is that if you do that, so this history at this location, there will be an error. Or not really. No, because we don't run the code. So agent ag equals new agent. Let me just improvise here for a second. So zx is here. Okay. So the problem will be that we'll have an error here, and this says object reference not set to an instance of an object. Line 82. It's not really common to see the actual line because it usually says line 0, which doesn't give you any information. But in this case, it actually gives you. Line 82 is this history at, right? The problem is that when I define the property as a list of points, I don't say exactly, is it already existing a list, or is the list which I will create in the future? In the newer versions of C#, we can do that. Right? But in this version of C#, It's not possible. What it means in the like in any other editor, this will create this instance, the list right away when you define the property. But what we have to do, we have to define the history in the constructor. So this history is equal to a new list of point3d, and we have to define it in both constructors. Oh man, this is really annoying. This list of point3d. Okay, and we do that for both of those guys, right? So now when we go here in the move, this list will already exist, right? Because just defining it doesn't mean that it exists. Okay, so as you see, even as I said before, even in a parameterless constructor, there might be something happening in the constructor, just as we do here. Now, there's a small interruption. Let's say, yeah, because we're talking about all of those types, but yeah, we're talking about all of the types, but really what you want to get familiar with is the Rhino common documentation, right? So I know those types like point and vector because, well, trial and error, but also documentation, right? So in the documentation, you can see the entire, uh, well, list of things which you can do in Rhino in .NET, right? And the really interesting namespace is Rhino geometry, right? So Rhino geometry. And in Rhino geometry, you have a list of all the geometry types which you want to work with and some structures, right? So structures, again, structures will be, I mean, they can be as complex as classes, but they behave like value types, more or less. And you can see that point, 3D, line, circle, this will be structures, right? Classes will be more complex usually, uh, like curves, B-reps, meshes, and I don't know, extrusions, lerps curve. Yeah, quite a lot. Polyline is a class as well. So this is a list of all the things which you can create. And now let's say that let's see the polyline, right? So let's see the polyline. And if we read the documentation here, okay, so as we say, inheritance means that the polyline class already has some code from another classes, right? So if you take a look at what is in the polyline, we can see that the polyline inherits from a point3d list, and the point3d list inherits from Rhino list of point3d, and Rhino list inherits from object. Everything essentially inherits from object, right? So this is the object class in system. Yeah, so this is a system assembly. So system provides us with objects, and then you can write your own object based on that. And we know that if polyline is inheriting point3d list, point3d list will have some functions or methods, which will be also defined by the polyline later on, right? So you can use the same stuff as you do in point3d list in your polyline. But polyline will add some more. So it inherits, okay, so it actually inherits point3d list, and iClonable is actually implementation of an interface. So it's not really an inheritance, but anyway. Point3d list is what it inherits. I stands for interface, so this is usually indicating that there is some interfaces, but let's not get too complicated. Inheritance is the most important thing which you really need to know first, and this is what it is. So it inherits from point3d list, and this is a polyline, and let's say when we have constructors for the polyline, we have a constructor which takes enumerable of point3d. Enumerable is an interface. Whatever inherits, whatever implements that interface will be compatible with that constructor. And actually, enumerable of point3d will be an array of points, a list of points, any kind of collection of points, or another polyline, right? Or not really? No, point3d list probably. Yeah. Anyway, it's quite complicated. Like the inheritance tree implementations of different interfaces. This is like it gets really complex, right? And it's really hard to tell sometimes whether something will work or not. It's sometimes easier to just run it and see if it fails. But when you see something like that, IEnumerable, it's quite common interface to implement, and most collections will have it. So any collection of point 3D will be compatible with the constructor. Let's get some use out of that. So when I create my agent, I have AG move, right? And I move it upwards. And this agent will move by first, it will add the current location to the history and then move the location, right? So maybe let's create a for loop, just like we did before. Let's take 10 steps and let's put the AG move in here. And let's do the same. Yeah, let's do the same if statement. So if I modulo 2 is equal to 0, and then else, right? So just to get you like familiar with that, right? So we are not really, yeah, reinventing everything. We are just using what we already have. So you can see that every second loop will move the agent whether either in z-axis or x-axis. Yeah, so okay, so what I'm using here is actually a property of a class, not a property of an instance of a class or a structure. Vector 3D dot will show me things which are like default vectors, right? It has a couple of default vectors 3D to use, right? So it's called a static method, right? Static method means that it doesn't require an instance of a vector 3D to get it to work, right? Whichever type you type, like mesh, it will have sometimes some functions, some static functions, or some static functions which return you a thing, like point 3D dot origin will give you a point with 0, 0, 0 coordinates, right? So static. We can have a static agent as well, like static agent function later on. So you'll see what it really does. Okay, so we have this one. And now let's say, notice that every time I have the agent move, it actually saves the location. So if I type a equals ag history, I should get the list of points in here, right? In the component. Okay. Okay, so let's take a look again at the Rhino command documentation. As you can see that my polyline, to create a polyline, I need a list or some collection of points, I number of points. And surprise, the AG history as a list of points is compatible with that, so we can do polyline. I will define it here, right? So I'll say polyline PL is equal to a new polyline, and I will pass the AG history as an argument. And now instead of points, I'll have a polyline, right? Yeah, so this is it. Of course, the agent location is not in the history, so you may want to add it, right? So maybe you can have PL add AG location. Yeah, it's 1 point more because we don't store the current location in the history, so it's there. Yeah, so this is our agents. Now we will make agent which moves in. I mean, do we want to do that really? Yeah, we have 2 more hours, let's say, like 2.5 hours. I'm just trying to think like whether we want to go with. Yeah, let's do the full thing. Like let's do the random walker first, and then let's do the poster image. I think we'll do that in this time because we like this code, we will just copy paste it a couple of times and just add some more stuff to it. So that's the thing which we want to do. Now we will have, I think, like in 10 minutes, maybe 15 minutes, we'll have a short, like a 15-minute break. There's like a one longer break where I need to really drink something, and then like some water, and then we need to continue. Uh, what should we do now? I mean, we have agents. Okay. Okay, you know what? Let's leave this guy here as a good example of very simple agent. Let's copy paste it, and let's change this component here, right? So I want to have a random walker, which is just an agent which walks in random directions. So I will leave actually that, right? And now, this is the same, right? It's just no polyline here. And in this loop, I want to move this agent in random directions. So there is like 3 or 4 different ways of how you can do it. One is to create a random vector in the loop and then just move the agent in the random direction. Another way is to create a function within the agent which does that in the agent, right? So we can have random move function in the agent where we don't have to define the random vector outside. But then we'll have another problem because this function here, random, if you know random component in Grasshopper, you know that random, I mean, it can work with no seed provided, but then the random seed will be taken from the system time. But we actually want to have a seed provided. So seed is essentially, I always describe it as random class being a huge book of random numbers. So the seed is the page from which you read the numbers, right? Seed is just a number on which it's a parameter for the random number generator, right? So the 2 random number generators with the same seed number will produce exactly the same set of numbers, right? But I describe it always as seed being the page of a really large book from which you read the numbers. So I said the random seed here is 1 to 3. And now maybe we can do it like properly object oriented. So if I were to like make it totally encapsulated within the agent, I would create the random in the agent. But I really want to have just one random class, right? Because if I have 1,000 agents, I would have 1,000 random classes in the agents. So I want to have just one random class, but share it across different agents. So I do it by specifying the class here, but then having a function in here. So maybe we can have public void move random, and then in the function argument, I can say I want to have a random, and I will call it. Well, let's call it RND as well, right? So when I will say, okay, so before we do anything here, we can actually say ag move random. And you can see it requires us to provide it with some random number generators. So we'll use this guy here. Don't be confused. This RND is only passed here, right? The name doesn't do anything. We can call this one differently. This can be just random, right? Maybe it's better to name it that way so it's not confusing, right? There can be more randoms here, right? And we can pass different randoms to different agents, right? So, so I really know this can be confusing. I just want you to think that, don't think that this is the same random here and there. It's passed there, but it doesn't have to be that one, okay? Okay, so we have the move random, and In the loop up there, you can see that we actually pass this R&D guy to our move random function. And now when I work here, I will create a random vector. Now the problem with random vectors is that okay, let's use the whiteboard. Well, first of all, I'll just create it in 2D. 3D is not really. How do I clear it? Okay, so the problem with random numbers is that I will have two values, which will be from 0 to 1, and random number generator will just populate. Okay, wait, let's get how to make it thicker. Okay, the random number generator will just produce two numbers, right, between 0 and 1, and I will have a uniform distribution of those random numbers. But it means that the movement of the agent will not really be uniformly random, right? Because if you think about it, the agent, when it's here, if you assign it this vector, it's a much longer step than this vector, right? So all the steps of this agent in this direction will be shorter than the steps in this direction. So what you want to do, you want to limit this, right? So you want to create like a uniform random distribution with that. Oh, that's a rainbow. Okay, never mind. You want to create a random distribution of vectors, but all of them should be of the same length or potentially of the same length. So I want to limit this random distribution to this radius of 1. Okay. So what I will do, I will actually do it a bit differently because I will have, I don't know how to use this whiteboard. 1 second. Okay, I don't have a touch screen, so I think that's why. I want to have the X and Y, right? And I want to have a circle, and only from that circle, oh, okay, only from that circle I will actually get the points. So let's get the red pen. Right. So random distribution will create the points everywhere, but I will only put points slash vectors. It will put them everywhere, but I will only choose the ones within the circle. So it will create a uniform, let's say, random distribution of movement vectors, right? That's just one variation which I would like to do. So I will do, and here we can introduce the while loop. So again, while. This can actually be while true. Now this is important. If you will not, yeah, if you will not do everything as I do exactly on the screen, this may crash because while will run infinitely, right? It will take, yeah. Yeah, it can crash. So just do everything exactly as I do. So move random. First of all, I want to get a random vector. So let's say I will have vector 3D, vec, new vector. And here, let's do everything in 2D, right? So here we'll be doing random. Random has next double, right? Next double has values between 0 and 1, but I want it to be between -1 and 1. So you usually do it by subtracting 0.5 and adding 2. Wait, is it the right way? No. Subtract and subtract -5 and multiply. Yeah, by 2. That's correct. Okay, maybe just to make it clear. So double. Can we use X here? I think we can. So random next double minus 0.5 times 2. Now this has to be in parentheses. I would have to have a semicolon here. Every time you call random next double, it will give you another double, right? So don't be confused. New vector x, y, 0, right? Z is set to 0. And now, well, if we want to limit that, so first here I created the two numbers. Let's create a new whiteboard. So I created the two numbers. If I get the coordinates is here. So I created x, which is between -1 and 1, and y, which is -1 and 1. Now I want to see if that vector can be applied. I have to check whether the length of this vector is smaller than 1. Okay, so I say vector length, right? This is a property. Uh, let's do that. Okay, vector length. If it's a property, you don't put a parenthesis here. If it's a function, you have to put a parenthesis because you need to specify the arguments for the function, right? But if it's a property, it doesn't really need it. We'll simplify this code in a second. But if oh, we have to name it. So length. If length is smaller or equal than 1, then this means that particular instance of the agent moves. So we use another function. See, I have move random. I call another function from that move random move using that vector. Okay. And now, because this is in a while loop, some vectors, right? If I choose random vectors, some vectors will be outside of that circle. So I don't want to use that one to move it, right? That's why I have this if statement. So I want to skip on that. But if I get to the vector which is smaller than 1 in length, then I want to break this loop. So what I do is I call break. Break will exit the while loop or any other loop once you get to that point, right? So in that way, and only in that way, you can stop the while loop. Okay, so now when I have move random, yeah, it already did something, right? You can see that I changed this, so AG move random RND, and this actually moves randomly in different patterns. Now let's say it's 100, so there's just 100 random moves. Okay, so I see that there is a request to copy paste everything to a text file. I will actually send it to you as a Grasshopper file. So I can disable that, and you can just work with that C# component here. Can I put wait.
You could just send it to me if you want. I'll put it in the Dropbox.
Yeah, there should be a way to share it here on the chat.
I don't know if there is.
Yeah,
I don't think so.
I think it's just too many people here or something like that. Or maybe it's a webinar mode, maybe it doesn't work. But yeah, let's do that. Let's send it to, I'll just use Gmail.
Yeah.
And maybe this is a good point to make the longer break, because it's like 6:30. We'll have still like 2 hours to continue on that.
Sounds good.
Yeah. Okay. Yeah. Okay. So maybe we can have this 15-minute break, and we meet at 6:45. Yeah, 6:45. I'm sorry, I just muted myself. So. Yeah, so let's have this 15-minute break. I really need to have some water. Okay, so we can continue now with our agent. Let's just see where are we at. Yeah, you can see that this just produces always the same pattern of random movements. Now, if you want to change this pattern, you will have to change the seed of random. So if I change to something like that, or something like that, right, it's fine. It just always produces some different patterns. Yeah. Yeah, I'm looking at the questions and answers just to make sure that we are not missing anything here. Uh, yeah, okay, so yeah, there's a question about the history. So history basically is a list of points. So the agent stores the history, so the list of points, just to remember all the locations. So before we move the agent in space, it just saves the current location, and that way you have this trace of what it did in the past. Okay, so but it's a list of points essentially. Um, yeah. Okay. So I see that some of you got lost with the random, but that's fixed. Uh, Anyway, okay, I think it should be fine right now. So we have the agent, which is our random walker. We have the history, and yeah, you know how to create constructors, right? So we have two different constructors, empty and one parameter constructor, different properties, methods. So the move and move random are different methods. We have the while loop, if statement, for loop. Uh, yeah, and maybe we can have. mm, yeah, because the next thing which we will do is to introduce another class so that we have a field class. It will work just a bit differently than fields in Grasshopper, but it's it will interact with the agent. I mean, the agent will move in the field, and then the movement of the agent will change depending on the field. But then, do we really have anything which we need to repeat right now, or is there any block missing here? I mean, hmm. Yeah, I mean, it seems like we're done with that agent now. So I'm just gonna save this one. 1 second. Save this one, copy paste this script. Okay. And yeah, I just want to take a look, and maybe we can take a look at it together so that you know what to expect. Uh, Maybe we can take a look at this guy here. Hmm. Yeah, so this is what we want to do by the end of today. And we have something like hour and a half, maybe a bit more. And yeah, the pulling curve is not really important, but we'll have a class field, and I'll just describe what it does in a second. But field will be passed to the agent, and the agent will move in that field, right? So actually, yeah, I mean here it's written a bit differently, but I think overall we'll see. I mean, because we can have you can see that we have a vector move here. But the field is not passed to it. The field is used only to produce vectors, right? So we produce like accumulate the fields together and just add them to the vector. And this is fine. Like we could essentially take all of that and put it in the agent so that will like in this loop you will only call agent move in the vector fields. But this way is also good. Like to be honest, in this case, like you can see that we can put more or less code in the agent. I think the key question is what is the most readable way? And uh, of course, it's great if the main code, which we consider this the main code, right, is as short as possible. But also, the more stuff you put in classes and methods, the more obfuscated it is, and you need to provide correct or easy to understand description of methods, right? So when you see the agent move, you know that it simply moves the agent, right? But if you have move and then move with fields and move with fields and maybe some obstacles, or move with fields with some non-uniform velocity, whatever, this just becomes a bit too much unless you have a very specific library which you work on and you want to have those, like very specific functions. But generally, you want to have it somewhere in between, right? You want to see it as much explicit code as possible, but also readable to other people, right? I mean, uh, like once you start coding, you will quickly learn, like after half a year, that you no more understand the code which you wrote like half a year ago. And it's good to that just write it in a way that it's consistent, so you always know where to look at to get an understanding of your past code. So yeah, it's a big topic anyway. So compared to what we have right now, we have a bit more functions here. So I created this helper function which creates a random vector, but also we have the field class. Pulling curve, it didn't really work that well, so we may skip it. Append mesh is not necessary. We may add it if it's really slow. Helpers is the uniform random. Node is the static here. We'll talk about that, and we'll actually do it the same way. Agent is the agent which we have right now, but here we have a bit more. So we have the history, location, but also direction, momentum, and terminal velocity. So there is a bit more to agent. And now this is, so far what we did with the agent was just moving it randomly. So you can imagine doing that without having a class and simply having a list of points and adding random vectors to the list of points. But the moment you want to introduce some more variables to the movement, like momentum, the terminal velocity, when you have a momentum, you also want to store the direction of the movement of the velocity, right? The velocity vector. The moment you add all of that, you could do that without agents, without objects. You could store everything in an array, like the velocities for each agent, the momentums for each agent, and so on. But because of object-oriented programming, you just put everything in the class of agent, and you don't have to worry about where it is, right? You just have a list of agents, and they store all of those properties. So this is the key benefit of using object-oriented programming, right? Now what we have else here is we have agent, but we also have static constructors here. So you can see that static, we'll discuss that, but we already did kind of. So agent spawn it's not really a static constructor, it's a static function, right? Which returns us an agent, but I don't have to create an agent to call this class, right? Because it's static, we'll see that. And one way is to spawn it from a circle, the other one is to spawn it from a box. When we have it from a circle, we maybe can then do diffusion limited aggregation if we have some more time. But if not, we'll just do that spawn with a box and check collision with a mesh. We don't need that because this is for DLA, the diffusion limited aggregation. But we need to move, right? So we'll see how much time we'll have. Of course, I will send you this entire code anyway. But yeah, this is essentially want to strip it down. But I will have this code. You have to. Yeah, yeah. Just to be honest, I'm not writing everything from my memory because I don't really have that great memory. So I'll just put it on the side here. Just if I don't. Yeah, there's a lot of different ways of writing agents, especially when you consider momentum and velocities and how you add the velocity to the how you add the new force to the existing force. You can, I mean, in a physical way, like if you consider physics, there is one way, but if you consider coding, you can just do it in a lot of different ways, right? So let's start again, and maybe we can get the last script from the webinar. Okay, so I'll just start from this guy. Is this the same? Yeah. Yeah. So I just copy paste this random walker here, and I'll get the code cleaned up a bit, right? So we will need that. This is not really necessary. Yeah, we kind of want to always trace the pole line, right? So I'll leave that. But here in this loop, I'll just move it in a field, right? So, but maybe before the field. Okay, I'm sorry. I'm just getting it a bit. Yeah, I'm just trying to think like what will be the best way to get to the point. But I think that it will be to first get the agent some more properties, right? As you saw, we have momentum. So we have history, location, now the direction, so the current direction. Maybe I can add it here. So this will be a public vector 3D direction. Right. We also want to have a public double momentum. Also get set, right? This is, yeah, we want to set it as well. So public double momentum and terminal velocity, I will just call it max speed. Okay, that's fine. It's max speed. So we have more of those properties. I added those properties, nothing really happens, right? It's exactly the same. So we need to change it somehow. Now you can see that I have two methods. I have move and move random. So if I change the move method, it will also change the move random. If I change move random, it will not change the move, of course, right? So what I want to do here, I want to move the agent, but in a way that we include the momentum and the direction in it, right? So we'll get yeah, we need to change the direction of the agent somehow with the vector, right? So we do it by saying direction, right? So you see that this is a property of agent. You don't really need to add this, but I'm adding this just because it's a bit clearer. So this direction is equal to vector, right? So the new vector, right? Plus oops. Okay, I'm sorry, something. I'm not sure why, but my laptop just blacked out. Is it still running? Are you still there?
I still see your screen.
Yeah,
But
it was blacked out. Just both screens just blacked out for a second. I'm not really. Yeah, I wasn't really sure if it's still running. Anyway, so yeah, so the direction. So in the move method, we have to change the location, of course, but we also need to change the direction. And you see that this time we have this direction is equal to the vector, so the new movement plus direction, so exactly the same, times momentum, right? So what it does, it multiplies. So first, when you have plus and multiplication in one line, it first multiplies, right? Then adds. So direction is first of all multiplied by the momentum. Momentum can be a very small value, right? So we have some old movement, some old direction, velocity, right? we multiplied by momentum, and we added to the new vector, right? So and we added to the new vector, and we assign it to direction, right? So that is actually the order of operations is actually from right to left, right? So direction times momentum, and then vector plus that. But what happens if the vector is too large, right? Or if adding this direction times momentum, if this is larger than our max speed, well, we can try to do that. So let's see, this location, now we had this location plus vector, but now we have the direction, so we do this direction, right? Okay, I'm not sure why it doesn't change anything. Is it really changing that? Okay, let me. Oh, momentum is 0. I'm sorry. So momentum here is 0. We need to set it to some value. So when momentum is 0, it simplifies this to just the old value. So direction times momentum is 0. So we just leave with vector. So in the constructor, we need to provide it with some value for momentum. So this momentum is equal to 0.01. So just 1% of the old movement will be added to the new movement, right? Yeah, and you see it change the path a bit. So maybe we can add a bit more. So maybe we can add like 10%. So 0.1. Okay. Maybe more. Maybe 5. Yeah, now it's a bit more. Yeah, so now you see that the momentum actually has some impact on the movement. I remember Jan Pernetsky always did like 0.9 or something like that, which is, just smoothing out the curve quite a lot, right? But then, okay, let's leave with 0.8. This is fine. We can explode the curve. What I want to see right now is to show you what is the terminal velocity for, right? You can see now that sometimes the length of the step is just a bit too much. I would like the terminal velocity to be equal to 1, so that at most the agent moves by 1 unit. So that's why I want to say that this term, the max speed is equal to 1. Yeah, so maybe just to add, when you say public double momentum, by default double is 0, right? Int as well. Most numbers are 0 by default. So this is why it didn't work, first of all. So when I have max speed is equal to 1, well, how do I introduce it to this equation, right? You see that this direction is a vector, and we need to limit this direction to some value, to 1, right? So first of all, I will have a local copy of that direction here, so it will be called vec. And we can say like that, right? Again, this is not really necessary if you have only one thing called direction, right? It's just here. Vec length, right? Because I want it to be 1 or smaller than 1. So I want to measure the length, double length. Right. Now I want to make sure that, okay, so there is a function which will trim the length value, right? So this double, if it's more than 1, will get trimmed to 1. So it's called, the full name of this function is system. That's the namespace, right? System math min, right? So minimal value of 2. But because this class, this script already imports, so using system, we don't need to put the system, right? If it's using system library, then we don't have to put the system here, right? So it's just math min, len and 1, okay? So the length will be the smaller one of the length and 1. And we can now say that we want to multiply this value by, I mean the vector by this value. So we say vec unitize, right? This is a function. So it makes the vector equal to 1. And now we multiply it by length, okay? And finally, we say that this direction is equal to 1, to vec. Now you see that I took the direction as a local value here, right? So local variable, vec. I modified it here and then assigned it back to this direction. That is exactly the same way we would do with a list, for instance, right? There was a question I remember about how would you assign this point back to the list. You would put it back on the list, right? This is exactly here. We take the vector, change the vector, and then assign it back to the direction, right? Again, this is what you do with value types, structures, and value types. With reference types, that is classes, you don't really need to do that, right? Yeah. You may ask, what happens if a class has a property of double if we reference it locally, right? Would I change the double in the class? To be honest, it really depends. No, it doesn't depend. If it's a property, you change it in the class. But if it's a field in a class, then you change it just as if it was a struct or a value type. But if it's a property, you don't need to do that. Yeah, correct me if I'm wrong. I think it's really confusing even for me. So I just try that. Usually works. But yeah, to be honest, the clearer way is just to always have this local variable, modify it, and then assign it back to the property, just as we did here. Vector, I mean, to make it even more complicated, vector is also a value type. So anyway, we have this. Now, if I run it again, you'll see that if I compile it again, yeah, you'll see that it changes so that the maximal step is at most 1, right? Which is really nice because we can have, we will not have those. If you know Kangaroo 1 especially, you know that if you change the proper, like some values to small or large values, particles exploded, and because there was no terminal velocity for them, right? So if they had some terminal velocity, maybe it could trim this explosion or not really be so unpredictable sometimes. Kangaroo 2 fixes that, but Kangaroo 1 was this a bit problematic. So so this is what we do with moving. Now I would like to get the field done, okay? So field will be just another class. And those fields, right, which we have in vector field. We have like a vector force and point charge. The field which I want to create is something in between those two. So the vector force here, it really has just the line, and it gives the same vector to all of the values in the field, right? But what I want to do is I want to assign different vectors to different locations in space, right? And this is something in between, right? It will have a location in space, the field, and a vector. And the closer you are to the location in space, the larger the force will be. Okay, so so this is what we will create right now. And this class will be called just field, right? So field. Okay, as I said, we have actually 3 properties here. It will not work exactly like the fields in Grasshopper, so don't be don't compare them to each other because they just work a bit differently. So point 3D location get set. Then we have vector 3D as direction. Okay, last but not least, radius, right? So Okay, so you may see that we have the radius just to change the actual force which the field has, depending on the location. So first of all, uh, no, not here. Okay. First, we'll create a constructor, right? Field, and usually when you use like Visual Studio, for instance, when you select those properties, there is like a hint what you can do, like a helper function in Visual Studio, and you create a constructor. It will name those inputs for the constructor with lowercase letters. So that's what we're gonna do because that's understandable for anyone using like Visual Studio or any other code editor. You can see that those inputs for the constructor are simply the same values as the fields which we are gonna use. So location is location. Now, when you have location lowercase and location uppercase, it will distinguish between that input for the field constructor and that location as property of this field. So we don't need to put this, right? You could, yeah, you could have actually direction named exactly like the property, but then you would have to put this in front, right? Just like that, okay, just so you know. But this is a bit confusing, right? So we do that with small letter, that is upper case, and then there is lowercase. Then finally radius. Okay. Now in Visual Studio, all of that can be done with 2 clicks, right? Because it has some really nice features, but yeah, it's also good to know how to do it from scratch. Yeah, so this field will have just one function, and this function will give us a vector, right? So we say public vector 3D get force, and get force will have one input parameter, which will be agent. So we have agent. So first, as we said, the field will have a different force depending on the distance to the agent. So we'll say, what is the distance to agent? Double distance agent location. And location is a point 3D, so we can say distance to other point, right? This location. Okay. So this is our distance from field to the agent, right? Then we have, yeah, so what I want to do is this inverse square function, right? So the force which will act on the agent will look like that, right? So the further, 1 second. Yeah, I mean, yeah, it will work. But anyway, the further away from the from the field center, right? So if this is a field, this is the agent. The further away, the smaller the value will be, but also this will decay with this inverse square 1 over x squared function. Now I could, yeah, okay. I'm just looking at it right now, but it's you can do it in different ways, but maybe it's not the best way. But so what we want to do, first of all, I want to create. If this force, I mean, if this field has some radius r, right? So this is r, then this point in this inverse square has to be r, right? And I do it by saying that the distance, so let's say d, I put it somewhere here, but I to get this, I just use intervals. So intervals are essentially two numbers, right? So we have 0 to, let's say, 10. This is an interval in Rhino. And if I the normal if I put the distance 5, right, I will see that the value of this interval at 5 is 0.5. Okay, and if it's like remap numbers in Grasshopper, if that tells you something, right? And then I'm gonna use that 0.5 and square it, right? And that will give me this inverse function. This will be actually 10 to 0 anyway. We'll see. But just to those of you who know Grasshopper, what we are going to do, we are going to create a range from 10 to 0 and use sort of a graph mapper, right, to modify it, right, to get this value of the field in the point. So first of all, I want to, if the point is too far, if the agent is too far away from the field, I don't want to do anything, right? I want to return null vector or vector 0. So if this distance is larger than radius, then return vector 3D 0. Okay, so this line, if statement, as we said, okay, we did before the if statement, which looked like that with parentheses here, but if the if statement has just one line of code, you can put it in one line, just like that, with no curly brackets. And everything after return, like if this statement will be true, everything after that return after that line will not be executed, right? Because we returned here and this function goes no more. So here we are with that. And now, as I said, we want to create this range. So it's in Rhino command, it's called interval, ITV, I'll just call it that way, new interval. And this is radius to 0, okay? Yeah, so this is this point where we have, let's say, this radius. And I say that force here is 10, force here is 0. And depending on the agent location, this will be smaller or larger. But I want to have it somehow unified in a way that I don't want to operate with the value of 10 or 100 or be it, I don't know, 35 or something like that. So I would like to have a normalized value of this force in this location of the agent. So I say double normalized is equal to ITV, so interval. An interval has this function which is called normalized parameter at, and here I say distance, right? And by this point, I know that the distance has to be smaller than radius. So I know that this normalized parameter will be normalized actually, right? And yeah, that's it. And the distance can be only positive, right? So that's another thing, because if the distance could be negative, then this could be somewhere between, now I'm a bit confused myself, but it could be between negative infinity and 1 or 0 and positive infinity. But anyway, this way we normalize. So we have interval from, let's say, radius 10, right? We say normalized value of that distance. The distance could be 5, so normalized value will be 0.5. Finally, we want to have that inverse square characteristic, right? So I don't want that force to be half of the max force here. I want it to be 1/4. So I will have this inverse function. And to get that inverse function, you just do normalized times normalized. Not that complex, right? And finally, we have to return the vector because that just computes the magnitude of that vector, right? The multiplier for that force. So it's not really magnitude, it's just the multiplier. So we return direction. So that's the direction of the force in that field. And direction times normalized. Okay. And that's it when it comes to the field. Like there is nothing more. It's just that one function. But yeah, it's quite complicated. You could probably do it somehow easier, but for those of you who know Grasshopper, I just think that this is the most natural way of operating, right? Especially with remap numbers, graph mappers, and so on. Like this is the closest which you can get. Okay, so we have field and agent. Now let's do the. Yeah, now we have the agent, we have field. I would like to get the agent to move. Yeah, maybe we can say, because here we have move random and we just move it randomly in 2D, but maybe in this case we want to move it in 3D because we have like those 3D fields. Let's do that. So let's have another value here in move random. Yeah, maybe, or maybe we just delete that. Yeah, I think I'll just delete that function because it's very specific to that random walker when this is quite generic, right? And here I'm adding, I will be moving the agent in the field, but this field will give me just a vector. And if I would like to have different weights for different forces acting on this agent, we would have to get all the forces as vectors and then mash them together, right? And if I have this move random here, as I have it here, well, it doesn't really give me a way to get a vector and mash it together with that field vector, right? So I would like to get this void and make it static and have it in a helper. So this is just another feature of C# language. I mean, it's really nice to know it actually because we get, okay, so maybe we can have, first of all, one second. Yeah, okay, so this, let's say public static helpers, public static class helpers. Okay, so this will not be a class which will instantiate like a field or an agent, right? In those cases, we have some instance of a field or an agent which is done in a way that we specified it in the description, right? But with helpers, with a static class, you will have a class which doesn't have an instance. It's just a piece of code which sits there and gets compiled, but it's not an object per se. It's just a bunch of functions. Okay. I mean, that's not really like accurate description, but it's. I think it's really like my purpose here is not really to overcomplicate it for you, but rather describe it in a way that you understand it without getting really into like how really compiler works, right? I think that's something which you don't get from books, right? Because I read a couple of books on coding and they always get like too deep, right? And it's just confusing. So in this case, static class doesn't really need an instance. Essentially, it's like a piece of code which just lays there and you can call it. You don't need to have a helper instance, right? It's just a way of organizing code, essentially. So I will get this move random. It's here, right? Move random. Put it to helpers. And well, I wanted to return a vector, right? So vector 3D. I can't remember right now if we need to put the public static here. Not really, I think. Anyway. And here, instead of this move, we do return vec, right? So instead of assigning it to the agent value, we just return it. Let me just put the button here. Yeah, okay, so this needs to be static as well. Okay, kind of doesn't make sense, but anyway. What's the problem? Con95. Oh yeah, well now we don't have it, so this doesn't really need to be here. And then unreachable code detected, line 95, is this break, because after a return there is no reason to have break. So we'll put it that way. Okay, just simplify it. As I said, if the if statement has one line, we just put it in one line. Single, I'll just put it description, single line if statement, one line of code, doesn't require curly brackets. Okay, so you see that here, when I have the agent, I have to create the agent with the constructor new agent to move it. With helpers class, I don't really need to create anything. I can just use helpers, move random, and then pass the random generator, and then it will just produce me a vector, right? So let's try it here. And I don't need to have this instance, right, of the helper. It just produces a random vector, right? So that is the difference between non-static and static, right? Yeah. Static is quite common, so it's good to understand this concept of static classes. In Visual Basic, it's called modules, right? But all in all, it's yeah, it's just a way of organizing code in a way that you don't really need an instance of an agent or field to run this code. Yeah, let's clean this as well. Okay, so we have way of random vectors, fields, agents. Is there anything else that you need? Yeah, I have this static function in an agent, which I use to create agents quickly. Okay, because if I would like to have a random location and direction for the agent defined in somewhere in here, I would have to define those values and actually assign them to the agent. And if I have 100 agents, I would have to do it in the loop. But to simplify it, I would like to have a function here. So it will be a static function, okay, public static, right? So you see that a non-static class can have a static function. This function will return an agent, and I'll call it spawn, right? And spawning an agent will require a box. I'll call it just box. And yeah, that's it. So somewhere in the box, there will be a random agent appearing, right? When I call this spawn function. So what exactly do I want to do in here? I want to simplify this entire process of getting the agent. So new agent. We can have just empty constructor here. And now we need to assign, of course, so in this empty constructor, I already have the history, momentum, and max speed, right? This calls this. I already have those three values. So history, momentum, max speed. I need to specify direction and location. Oh, this function will also require a random number generator. So we say random RND. Yeah, so here I will say that the agent location is equal to box point at, and here I can evaluate the box with 0 to 1 domains, right? So it's RND next double, 0 to 1, RND next double, 0 to 1, RND next double, that's 0 to 1 as well, right? So this will give me just a random location in that box. And now I need to get some direction, right? So some velocity for the agent. And I'll do it by calling our helpers function. So direction is equal helpers, move random, RMD. Okay, see? That is we are doing a very complex operation here by putting very simple methods together, like this helper, move random. That is the essence of object-oriented programming, right? Or just, let's say, higher level languages, let's say, to be honest, right? But yeah, this is yeah, this is just, yeah, so we have like quite a complex system here, which we can now run, but we need to set it up. Okay, so there is some error here. Okay, 140. This one, spawn. Oh, we need to return it. So return agent. Okay. Okay, so I have this code. Let's save it. Okay, so as with let me just take a look. So as with yeah, as with Grasshopper components and like everything what we do in Grasshopper, we need to define the input for this, right? So this component right now, first of all, I mean, and hopefully we'll have enough time, but I'll try to make it quickly. We'll define all the inputs for this code and then run it, and then we'll define it in a way that just a second, in a way that we can use either Anemone or a timer. Okay, I know that for some of you Anemone doesn't work. I think that's mostly Mac users because Rhino 7 or even Rhino 6 did somehow break it. And yeah, I need to investigate that, but yeah. But we can use timer for that as well. Yeah, just a second. I'm sorry, I was just looking at the clock actually. But yeah, we have. Yeah, okay, so someone says that Anemone works fine on macOS. Okay, I think that some people have sometimes problems with Anemone. I don't really know why, but. Okay, so we need to define inputs. So you see that right now I was just describing, like I was writing the agent and random with, you know, 100 of loops here. It just all fixed, but I want to change it with parameters in Grasshopper. And then later on, I want to, let's say, use Anemone to actually animate that. But first of all, let's try to use what we have here. That is, yeah, let's see what we actually need in the input. So we need the box, right? So I'll call it spawn box, right? For the agent. We need the field, right? So the field has direction, location, and radius. I'll use the same radius for all the fields, but locations and directions will be a list. So I'll call it f log and f there, and let's say f radius. Right? So f is just to distinguish it from other inputs. Now we have iterations here. So each agent will have, or maybe all of the agents will have a number of iterations to move in that field, right? And then agents will be the number of agents we want to have. Now we need to set the types. So the spawn box will be a box, it should be somewhere here, right? F log will be type point, F dir will be type vector, radius will be double. If you get lost right now, once we open the script, you will see those types so you can catch up. But anyway, type hind int, type hind int. So two integers, double, vector, point 3D, box. Those two need to be list. Right, so flog and fdir needs to be list. I don't know why is there a red probably, yeah, there's some red issue here, but Hmm. I think we have a problem with that. Yeah, I remember experiencing that when I wrote it. I think F there is somehow, yeah, I think F there is some kind of keyword or forbidden word or whatever. It just doesn't work. Yeah, let's name it F location, F locations, F directions, F radius. So this is for the field, this is for the box. Yeah, I'm sorry. Let's create a box. So I'll just right click, set one box, and from 0 to 100 is fine. Now, please note that we are operating with 0 to 1 domain when it comes to movement, so 100 gives the agents quite a lot of room. Well, field locations, I'll use populate 3D with that same box. Oops. Yeah, that's what happens sometimes. Yeah, I'm not sure if it will. Yeah, hopefully the code, when you actually have the C# code and everything breaks, yeah, this will take a while. Let's restart Rhino. Uh, I'll show you one feature of the scripting component which can save you a lot of time. So let's do it again. Yeah, so what it did actually, it wanted to convert box to a number or in the populate 3D, and I think it used volume. So I think when it wanted to create 1 million points, so it will take a lot of time. The populate 3D component is not like super fast. It's actually nice when it comes to distribution, right? It creates a really nice distribution, but it's yeah. Let's see. Okay, there is some autosave. Okay, so one that everything app which I'm using that's really nice. You just Google everything search and this is really great. You can it even shows you like files from the bin. So that's one way of saving your data. Another way is to go to the C# component. So if you have everything just lost, you can yeah. So if you have that script, you can actually take a look at this recover from cache, and we can recover it just like that. All of the script which we wrote so far are actually in the cache. You can clean the cache, but well, why would you? There are just some temporary files somewhere on the hard drive. So we have all of that here. Yeah, it even has the properties set, like the text, the properties are actually set to the proper values. Yeah, but the direction is not. It's just before everything broke. Yeah, and I'm gonna use this one. It's gonna be a bit faster. So yeah, again, maybe we can say again what are the values, and I'll save this as webinar 2. Yeah, but that recovering from cache is really useful. Like it's the most like the most recent compilation of that script which you did. So usually it's quite fresh, and yeah, it's hard to lose anything. But you have to go with yeah with those inputs, right? So it's spawn box, F locations, F directions, F radius. Then we have iterations. Finally, agents. Now the spawn box is again a box. F locations is a list of points. F directions is a list of vectors. F radius is a double. And iterations and agents are both integers, so ints. Now again, if you didn't catch up with that, when I double click here, you can see all of those types in here. Right? Those are the types. So yeah. Now I'm just gonna get box again. So we give it 0 to 100 again. Populate 3D. And now let's put the box. I mean, I logged the solver. I'm getting smarter, right? So it's here. And let's say that we have those. Now with directions, it's yeah. What we can do, we can actually take this helper function. So this is actually quite nice. We can copy this helper to another C# script, put it in here, and then say it's A equals helpers. Well, move random. I mean, it just it's a name, not really fortunate. And here we do. Well, let's say we do random RD random. Why am I doing it that way rather than having some random component in Grasshopper? It's just simpler, and it creates this nice uniform distribution of those vectors, right? So here we do vector 3D vectors list, or maybe we can simplify it, right? So we have R&D A is equal helpers move random R&D. Now we have to change the X input to integer, right? So this X input will be an integer, and here we'll have a series, and let's say 100. So 100 locations, 100 vectors. Okay, let's see it. Okay. See, so I'm running this script with different seed values, so it gives me 100 different. What? Oh, it's here. 100 different vectors, right? So X is just integer, right? So I'm creating 100 randoms, and I create 100 vectors out of that. So this is fun. This could be here, right? Now the radius will be, I think something like 25. That work fine. We can change it. And then iterations and agents. For now, let's stick with 10 for each, right? Because we don't want to crash your laptops. So we'll start with 10, introduce more if you can see, if you see that it actually still works. Okay. Okay. Okay, so yeah. Okay, so we have everything right now to create those curves. And then, yeah, we'll see how it works. So we have, I'm sorry. Instead of one agent, we want to have as many agents as we have specified in the int, right? So we do it by specifying a list of agents. Do we really need that? Yeah, let's do it that way. So list of agents, the list of agents. Okay. Then we have a list of fields, right? Fields. New list of fields. Yeah, let's code with. Okay. Yeah, this editor is not great. Let's see. Okay. And then we have, first we need to create agents and fields. So I'm going to start with agents by counting to agents, right? And I'll say agents, add. And here, please note that we are using the static function from agent, right? So I created the agent class, And here I have this static function spawn, right? So here I'm going to add the agent by calling this function, agent spawn. And the box is the spawn box. So this is the box from the component input. And the random is the random which I defined here in the script, right here. Okay. Then we have yeah. So we have the agents, we have fields, and let's do the fields in another loop. And the length of the loop is f locations count. So the count is a property of f locations list of points, right? And we do fields, add, new field, right? And we need the location, so the location will be f locations, right? So you remember the syntax from collections, right? This is a indexer, a square bracket after a list or after actually anything after some property. A square bracket will be called indexer. It's a very unique square bracket, let's say. So this gives us the ith location from f locations. Then we need directions. So f directions I. Finally, f radius for all of them, the same radius, right? So let's try to run it. Let's see if it works. Nothing crashes. Yep, it's fine. And so we just created the setup, right? Now we want to have this master loop, right, which we will call for I to I smaller than iterations, right? So I create everything. Now for the number of iterations, I want to run this setup. So in these iterations, I will run agents in the field. So for each agent, yeah, so for, yeah, and when I have a for loop in a for loop, by default, the I value is called I as well, but you can say usually it's I, J, and then another nesting is K. Or if you really need to go further, it's P, Q, and R, but usually you just go I, J, K. So I, and for another loop is J, and here we say agents. Agents is another, yeah, maybe we can use the agents count. So this is a property of that list, not really a property of that input, just make it a bit more modular or self-dependent. Okay, so for the number of iterations, for each agent, what I want to do, I want to move the agent, right? So I take this agent. First, let's get this agent out. So agent AG is equal to agents J. Right? So I'm just getting it out of a list just because it's easier to type later on. First, yeah, we'll want to have that agent. We will call move, right, at some point. So we need some vector to move it with. And to get this vector, we need to sum all the vectors from all the fields. So for this agent, we are going to have a vector 3D sum, which is equal to, in the beginning, it will be just equal to vector 3D 0. Vector 3D 0 is a static property, like it's actually a property, is a static property of vector 3D, which returns you a vector 3D with 0, 0, 0 coordinates, right? So it's just a sum. We started. And now here it's quite interesting because we can introduce another type of loop. When I don't really care about the indexer, so about the number at which I'm at right now, right? When I don't need that, I can introduce for each. For each, and then press tab. Now var is Yeah, var is indicating that I don't really know what is the type, but the compiler will figure out for me what is the type, right? But I mean, it's fine to use it that way because you could do var item in fields, right? So in fields, and you can see when you say item, then not in this editor, but in a proper editor, it will actually show you the properties of a field. Uh, so what I do in that, instead of var, I want to say for each field, right? So it's now you have the field properties, but in the proper code editor, var item in fields would actually have the same result here. So it will be item direction, get force, and so on into the sense. So first we want to get the force. So vector 3D force item get force, and we pass the agent. Okay. And then we add that force to our sum. So sum force. Now notice that both sum and force are vectors, but if you add them, vector 3D actually understands how to add to another vector 3D. If you want to, I mean, you can create your class, you can create your structure as well. And if you want those to understand how to be added to another instance of the same type, what you want to do, you want to create operator overload, right? Operator means plus, minus, or other mathematical or not mathematical sign. And overload means that we are just overloading the default behavior or no behavior. So yeah, this is sum plus force, which means that our vector sum will increase by force, or will be added to force, or force will be added to the sum. And well, for now, let's not do any other vectors, because later on I want to add the vector for a random vector, but let's not do that right now. And I will call agent move with that guy, right? With our sum. Okay, so I mean, it seems like we are done with that part. Now we can, you can see that it will run for the 10 iterations. For each of the 10 agents, it will compute the sum at any point, and it will move the vector, and it will move the agents. But now we want to see the output, right? So as we did before, we had a poll line to illustrate the history of the agent locations. So we will want to do the same right now, and I will simply create a list of polyline. I'll call it polys is equal to new list polyline escape escape escape, and here for each agent item in agents, I'll say polys add new polyline. I mean, you should remember that from before, right? So item history, and the history is just a list of points, so it should be compatible, right? And here we say a equals false. Okay, I'll just run it, and I just want to see it. Okay, yeah, there is some polylines here. Maybe let's put it on the side of the screen. There is some polylines in here, but let's introduce. Yeah, I just want to leave everything open so we can still see that. But also at the same time, I want to introduce this. Let's introduce more iterations. Okay, so that's 1000 iterations. Maybe let's leave it to 50. I think 50 was just fine. And then a bit more agents, because right now you can see there is just 10 polylines. I just have 10 agents. Okay, let's have more agents. Okay, and this radius will be quite important. I will stay with like 200 agents, and that radius is how much influence this each of the fields has. Now, what I can change, because I'm not changing it, I'm just no, I'm just creating a default value for momentum and max speed. But maybe momentum can be a bit smaller. If it will be a bit smaller, I can't really say. Do we need that? Maybe we can. Anyway, let's say the momentum is 0.1. Yeah, if the momentum is 0.1, it's not really. Yeah, let's say 0.5 would be fine. Yeah, 0.8. And now it's all about tweaking those parameters, and I just want them to be hard coded, so it means that I don't want the slider to give it an input, right? But there's something like that. Is there anything else here? I mean, yeah, let's get more agents. More agents. Okay. Yeah, so this is just agents moving in those fields. Now, one thing maybe you want to see is to get the display of the fields. So this is this and this, right? So you can see those fields. We can also multiply the field vectors, right? We have like a max velocity for the agents, but multiplying them should also affect it. Right? So you can see that those fields are now getting more, just more radical forces, more influence. Yeah. Okay, and I just want one thing to change here. So set one box 0, 30, 30. I just noticed that it looks more like interesting when it's a bit more vertical. And maybe we can change the radius to smaller value, like 10. There is a dramatic difference between them, but I believe that's because of the radius, which really influences how everything works with, like, one with another. Yeah, but it should still. Yeah, maybe if we increase the momentum, right? So let's increase the momentum to 0.9 even. So that means that if there is no force acting on a point, something will still push it forward, like some past force, right? Will still keep moving forward. So even with smaller values, it should still produce like longer polylines. Yeah, let's stick with that. Okay, and now we have like half an hour, 45 minutes left. We want to have a Q&A. So right now what I want to do, because this is like the end of agents, but not really. There is still some more stuff to do, but I also want you to see how I did the boxing part. And another thing is, one second, another thing which we want to do is to animate it, right? So animation means that, yeah, we'll see. We'll see what exactly it means, but mhm. Okay, so let's start with the boxes, and I just want to have this, like, just so we have an image which we kind of have. So we have those 1000 polylines. Maybe let's reduce it to 50 for now. So we have those polylines. They're quite interesting. So polyline X is a polyline. I want to have two inputs, so 2. Yeah, let's go 2. let's say this will be large X and this will be large Y. This will be a double. What this script will do, it will divide the polyline into segments, and then from each segment it will create a box with X and Y values. Yeah, there is, I mean, it will be a bit different from what I did because I think there is just a better way of doing that. Let's call it just poly, so we just have an understanding of what it does. And here we'll do 10 by 3. Okay. This will be a double, this is a double, and this is a polyline. Okay. So what I want to do for each segment of the polyline, I want to create a box, and I will do it by finding a bounding box for that segment, and then finding width and depth and changing it to X and Y. It should work like kind of similar to what I did in the poster image. That method in the poster image wasn't that elegant, let's say. So, and do we want to create a mesh box? Is there a way? Box. Yeah, let's do it with meshes. So there will be a mesh. Why with meshes and not boxes? Because it's way faster to put everything into a single mesh, display-wise, right? So there'll be a new mesh. And now for each line, segment in poly, so polyline has get segments, right? You can again read those available functions from the Rhino common documentation, right? Let me see that. So it's, I mean, honestly, there is no better way of getting familiar with documentation than just coding and looking at the IntelliSense, because IntelliSense will show you those methods. But if you need some more explanation, I mean, all the descriptions are actually shown by IntelliSense as well, but sometimes they are just not readable, or sometimes it's just faster to go and see the Rhino geometry polyline and then just browse through the classes, through the methods and see what is available there, right? So polyline has, as you see, get segments, right? And this is what I'm using. So get an array of line segments that make up the entire polyline. So that's what I'm doing. For each line segment, line is a type, right? So this array of lines is enumerated here, right? Line segments in polyline get segments. So for each one, I will take a bounding box. So bounding box BB is equal to new bounding box. Let's see what are the constructors. Bounding box is a structure. So min max. Well, we can use min and max, right? Line has only 2 points anyway. So segment from, segment to, right? And we have a box. Now, bounding box is a structure. Anyway, let's see what happens if we take, like, with no modification, we'll just get this bounding box, have a mesh out of it. So let's say a mesh BBM is mesh from bounding box, right? So from box BB, and this is the number of faces in X, Y, and Z directions. We just set it to 1. We just need the simplest box. And now mesh append BBM. Okay. So to that mesh, I want to append all the boxes. Let's see what it creates. Okay, this is what it does. Some might be invalid. Yeah, it's quite common that stuff is invalid when you work with meshes, but anyway. So you see, for each segment, I create a bounding box. Now what I want to do, I want to replace the width and depth, or width and height, or whatever combination you want to, with X and Y values, right? So let's see what bounding box has, right? We cannot we cannot, there is no width, right, in bounding box. So we cannot really do that. What do you define bounding box with is the minimal and maximal point. And you can get or set, as you see, the property says gets or sets the point. So it's quite important that that you can set it, because it's not always true. So what I will do, I will create a vector from minimal point to maximal point, change the x and y components of this vector, and use that vector to translate the minimal point to a new location for the maximal point. Okay? And that way I'm kind of replacing width and depth of that box with x and y. Okay? So again, first of all, let's get the diagonal, and it's actually a property. So a vector 3D diagonal is equal diagonal, right? Now let's call it diag, right? Diag x is equal to x, diag y is equal to y, and now the BB max will be equal to BB mean plus diag, right? And let's see what it does. Okay. Yeah, so you see that now we can have something like that. Maybe instead of x and y, maybe I can make z. Maybe it's a bit more interesting. It's like that. Maybe different proportions. It's quite fast, as you see, with that many boxes. Let's insert it. Yeah, it's nice because this function creates really like valid boxes, which is really cool, because not like the method which I used for the poster was actually creating invalid boxes, and it never really wanted to display properly, so I had to repair it like semi-manually. And you can see that because we have everything in meshes, it takes almost no time to create it, right? This is like really fast. We could even speed it up by dividing this curve by the number of iterations, or maybe by its length. Yeah, so just like that. And then having a polyline, I think what it will do, it will simplify the curves, right? And make the boxes a bit more uniform, right? So both ways. And now it's even faster. Right? Well, up to you. So this is just to simplify the boxes. So simplify the curves, or the polylines actually, but never mind. So this is quite fast. Anyway, so this is this part. We would like to have more, right? So let's try with more agents. Yeah, it's quite fast, right? You can see it's a bit quicker than Anemone, for instance, right? Or anything which you can do in Grasshopper by hand. But yeah, it creates some nice geometry. We can try to create this and say y. It's nice to superimpose a couple of different geometries. So do it like that. Right. So now it's like it has a bit more like architectural feeling to it. Yeah, which is nice. And then we have, let's go. So this is, yeah, that's it. Now let's try to animate it. So what I mean by animation is that I don't want to compute all the agent positions in one go, because that's kind of, well, yeah, with more agents or with more complex agents, it will get really slow, and it's good to see the progress, right? And yeah, what I really want to do is to to have Anemone and let it loop the script. 1 second. I'm just trying to look for like if there are any questions here. Yeah, I should also show you how to get the other libraries to work with C#. But yeah, that's maybe as the last step. Okay, so let's design it somehow, right? What we do really need to animate is the yeah. What we really need to animate is the agents, I believe. But we would need to have a fixed number of agents. Or not really. Yeah, because usually when you have a loop, you want to loop something, right? And you want to get some geometry to be looped or some value. But here, nothing really loops here. It's just that, I mean, maybe a timer would be better here. Yeah, let's do it with the timer. Okay, maybe I will create a simple, like a very simple loop with Anemone, just so you know how to do it with Anemone, but this just doesn't have a good application here. So I'll do it with a timer. But just so you know how do you do it with Anemone here. Let's say you have a point. Second point, right? And let's say this is your location here, or something like that. Right, so let's say x transform a second, transform translate 0, 0, 1. So it will be just moving up, and a is equal to x, right? But essentially, this is the setup which you have with Anemone, right? You loop some geometry and you change it every time you pass it through this. But here, what we have is that loop is actually internal. So the loop with iterations is actually here. And if we were to somehow extract it and like put it together with Anemone, we would have quite a lot of things to pass around, not only agents, but also fields. And I just think it's maybe a bit better to explain it with timer. Okay, so what I want to create is to have, maybe let's get a copy of that. Okay, I'll disable, like I'll delete that from that copy. Okay, so delete that, delete that. Yeah, I see there is a question about passing agents between components. That's also something which we can do. But that would be maybe the last part, like when we talk about JSON and about getting libraries together. So we'll do those two questions together. We'll output agents from this component, get it to another component, and get a history out of those agents somewhere else. So this is just to see how we pass it. Now here, in this component, we'll want to have a button which will be called Boolean toggle, which we will call run, and then reset. So if you remember how Kangaroo worked, it actually still works like that. It's kind of similar to Kangaroo 2 solver. One will be called run, and the other one will be called reset. And maybe we can have a very quick look how exactly do we want to do that. So this is Boolean and this is Boolean as well. So bool value. But just so you know what exactly we want to do, we'll do like a test here. Here we'll use the timer. So here we'll see run and reset. Okay, so it's always the same like scheme to use with timer and Boolean values to loop something, right? So first of all, when you have a timer, what it really does, it simply runs this method, the run script method, right? So when you run something in here, it computes only this part. This part remains untouched. So if you say that you want to have some integer, right? So we can say something like that. You can output it here, right? Okay. And it stays the same, right? Even though the timer is ticking. So I would like to increment it. So I say count +1, right? And now every time the timer ticks, it increments the count. So this is what happens now. But yeah, if you want to reset it to 0, we need to say that, yeah, just to make it nice. So if reset, then else, do something else, right? So else here. So if we reset, we say that, well, this should actually go here as well. If we reset, we say that count is equal to 0. Okay, so if I say reset, it's 0, right? It doesn't increment it. But then I would like it to stop. So I don't want to reset it, I just want to stop it at some point. So that's what I have run for. So reset overrides everything, of course, but else if run, then count, okay? So that's why you need two Boolean toggles. One is for pausing, and the other one is for resetting it to the default value, right? So you can say that, okay, let it run for a while, right? So run true, reset 0, and start from beginning. And then run, set to false, it's 46, reset to 0, and run again. Okay, so this is always the same setup. Sometimes those if statements are in a different order, but this is exactly what we're going to use. Reset will put the values, like, so when we created the agents and fields, this will be when we have the reset, right? And else it will be the other loop. Okay, so maybe let's put this aside. Let's go back to our script. This is a copy of that script, so you may want to do a copy as well. And now let's map it. So first of all, this random agent and fields, this has to go here, right? Because in this custom additional code, it's here. Because we don't want it to, be subject of this run script, right? I mean, the creation only happens once, right? So creation of those values. Okay, so this goes here. Now we have this part, which is essentially resetting, right? So if reset, so we say this, if reset, right? We can basically copy paste this, right? But I will just write it by hand. So if reset, else, if run, and then output will be this, right? But this, because this police list will be defined in run script. It will be defined from scratch every time this script runs, right? So we leave it here outside of this scope. It will be the equivalent of a equal count, okay? This part. So we leave it as this. Now reset is those two first of those two loops, agents and fields. We want to fill them in with this, right? And then run is essentially this loop, iterations. Okay. Okay. So let's click OK. Let's see what it does. And now the iterations will be, so every time the timer ticks, the iterations will increase, right? I mean, there will be like 10 iterations running. And maybe let's start with 10 agents. Let's see what it does. Let's say the timer is set to 1 second. Okay. Yeah, and why it doesn't work? Because the reset has to be set to true once and then to false, right? Because in the reset part, this is where we actually get the values the agents created, right? Yeah, we can make it a bit more fluid by reducing the iterations to 1, for instance, and then changing the interval to 20 milliseconds. And then run can be just set to true all the time, and actually we just want to reset and run again. Oh, okay. I forgot about one thing here, which is when we reset, we want to clear the list of agents and fields. So agents clear. This is equivalent of saying count equals to 0, right? Fields clear. Okay, now we can do it that way. Can we? I can't remember if this version, yeah, it still works here. Okay, so if the for loop has one line, it can also be without curly brackets. So I'm just going to simplify it that way, just so that it's more compact. And then you can see it here. Yeah. Okay, and now let's run it. So reset is set to true. Let's run it now. Yeah. Let's say we want to have more agents. Right. Okay, but there will be one problem with that. This is that we have, it runs for a while, and then the polylines get longer and longer. So maybe we want to have a limit of how many points we want to store in the history of the agent. Okay, so let's try to do that. Let's try to say that history at, yeah, so it's not, okay, anyway, so if history count is, let's say, larger than 50, then history remove at 0. So the first item will be removed, okay, when it's longer than 50. That way it will only remember the last 50 iterations. You can see this, everything shortens here, right? And they eventually, why they are ending up in some locations and just stuck there, it's because the points, they get to some equilibrium state, essentially, right? So this is why this works like that. Anyway, so this is this bit. Now we have just about the time to discuss transferring the agents from one side to another, so from one component to another. We'll also do it here. So instead of getting the curves, we will get the agents and then get the curves out somewhere in another component. How can we do that? We can get the another component with C#, right? And now in uh, the files which we've sent you, I believe there was a link as well to Newton's soft JSON library. If you don't have it, you can download it. So just a second. So JSON is just this JavaScript-based serialization language. It's used all over the internet, and you can download it from the library from here, but also with all the package management software which is out there, especially in NuGet. So this is something which is integrated in Visual Studio. But yeah, I mean, in our case, we just want to download the zip file, so we just go here. We get that release, and I believe in this zip file, yeah, in this zip file there will be just this entire library. So I'm just going to open it. And I want to extract it, so I'll just extract it to my desktop, and then we'll see what's in there on the desktop. So oh, come on, new folder. Okay, extract. So once we extract it, yeah, this library comes with a couple of different compilations. I think in case of C# script, we need to use the compilation for .NET 3.5, but I may be wrong. Maybe it was updated to some higher version. I think it might have been updated, but anyway, it still uses like old C# language version, but I think the .NET version should be fine. So anyway, if we go here to JSON, in this folder, you have bin, so that's the binary files. And I mean, out of safety, let's use the .NET 3.5. And DLL is the file which you want to reference, right? So let's keep it here. And in our component in Grasshopper, what we want to do is we want to right-click, manage assemblies, add assembly here, and get to that folder. So bin, .NET 3.5, Newton JSON, Newton.json, okay? Failed to load it, why? I have no idea. Let's try again. Maybe it's locked. Yeah, okay, so it's probably locked, so let's unlock it. Okay. Yeah, now it's loaded, so manage assemblies, add it again. Okay, so in both of those components we have JSON, but to use it, I mean, you can still use it. You can say, you can type the full name, so Newtonsoft JSON convert, that's like the easiest one. And you can use it that way. But I'm going to use it by calling it directly. So I just want to have using here. Okay, so what it does, it imports this entire namespace. So all the values from, I mean, all the classes and everything from this library will be accessible directly. And I will get it by here. I'll create a list of, instead of list of polylines, I'll create a list of strings. So what JSON does, it serializes all the values. You know what, we can actually create a list. So it will serialize this entire list of agents into one string, and then in the other component we'll deserialize it. It means that, yeah, we'll have to do some, like, it's a hacky approach, but it works. So let's say we have JSON convert and the serialize object. And we have, yeah, let's say object value, and this will be agents. And we output it to A. Okay, it failed to load it. Let's do it again. I think that maybe we need a newer release, maybe 4.5. 4.5. I have no idea which one. I have no idea why it doesn't work, but let's try. Yeah, now it works. Yeah, it's an empty array, so empty list, so that's why it's here. Let's try to just refresh it again. Yeah, I'm gonna use this 4.5. It should be fine. Now nothing is really here because it's not running. Let's run it. So not reset and run. Now you can see it's a very long list of strings, and it makes this panel very, very unresponsive. To speed it up, you can get this string wrapped in something called new GH object wrapper. This is a special type in Grasshopper which tells Grasshopper not to display the entire string, basically. And this passes it as, wait, I think it's still the same. Wait a second. Oh, come on, it's still, okay, I think it still passes it as a string. Yeah, I mean, just don't plug in panel. That's the solution here. Or another way, instead of doing it that way, we can say we want to output a list of strings. Panel will be much faster in displaying the list of strings. Let's say outputs is a list of string. And then for each agent, we'll serialize each agent separately. So for each agent, AG in agents, outputs add JSON convert, serialize object, AG. Right. So, and then A equals outputs. Okay. So if you were to do it by hand, with just regular Grasshopper types, you would have to have as many outputs in the component as you have properties in the agent, which is not really that difficult for agent currently because it just has location, momentum, max velocity, you know, like a couple of properties. But with more properties, it just gets, you know, you have 10 components and you would have to have 10 inputs for each of those 10 components. That's maybe a lot of work, right? So all of those properties are now written down as text here, which means that in this component, when we get the list, I want to have it parsed item by item. So in this component, I can convert this text back into the agent, but I would have to inform this code here, this class, what is agent, okay? So I have to copy the code of the agent from here, copy, and paste it here, okay? Actually, we don't need any of the methods. We just need the properties because that's what really we care about, but doesn't matter. And here we need to have agent, ag is equal, I think this is how it works, but JSON Yeah, we need to do the using Newtonsoft JSON, right? So importing this namespace, Newtonsoft JSON. And here we say JSON convert deserialize object X, that's the input, right? And I want the type. So type of, that's a special keyword, which when you get the type, like agent, it will actually return a type rather than an object of this type, right? Should it work? Let's see if it works first. No, the best string. Oh, okay. So that's okay. We have some problem here. Let me see how. I mean, I have it somewhere prepared here. Uh, let me see, because there is like 5 different ways of doing that with JSON. Let me just see how I did it here. Okay, I have no idea why it doesn't work. Because oh, it has to be a string. I'm sorry. Yeah, because here we already don't have an object. We actually have a string. So this X has to be set to string. And helpers doesn't exist. Agent uses helpers to get the random vector. Let's copy it there as well. So usually in that setup, you would copy everything here, right? And then just have it passed, have it in this other scripting component. So I just have to have helpers here. Yeah. And now you can see that I have agents here. I can actually say A equal AG history, right? So for instance, right? So I can use this agent code in this. Okay, well, it's empty. It's possible that the history is not passed. No, it is passed. I think maybe it's because it's just empty. Yeah, it's fine. 1 second. 1 moment here. Okay, so we can see here that. Okay, stop. Okay. Yeah, see, so this component now outputs this history, right? And I can use encode with agents exactly here, but we just need to deserialize it. So that's by passing the values from one side to another by text. So this is one way. I mean, in the script which I've sent you, there was also another way, which was by reflection. And reflection is, I mean, it sort of seems to be like an advanced topic in C#, but eventually it's all about getting to know reflection namespace. You actually output, so here, just to discuss it, I will not write it because it's already there and it's like a one-liner. But you can see that here I have, on the left side of this, I have this. So I have some agent class, I create a new agent and I output it with a output, which works just fine. You can see what it does actually. Yeah, so it says a script instance plus agent. This is just the description of this class, and I think what it means is that the script instance has this class agent, and this is how it's described. Right? It's nested. So this class agent is nested within a script instance. Anyway, so we can output this agent that way. Of course, it will not be visible because Grasshopper doesn't know what do we want to display in this agent. But if you want to access some properties from another script, you can either do the JSON thing, which we did right now, but you can also use system reflection. System reflection is, let's say, giving you direct access to whatever object you want. And you can do quite a lot of stuff with reflection because almost no code in .NET is kind of safe, right? It's always possible to reflect it. There are actually some reflector applications like ILSpy, for instance. This one is like a freeware. It's not illegal to decompile because it's I mean, it's not really decompiling actually. The .NET doesn't really get compiled to a compiled language before you run the application. It actually gets pre-compiled to something called intermediate language, which is also human readable as well. But anyway, because of that pre-compilation, you actually get system reflection, right? And you can say that you want to access property of name location and you want to display it here. And that's essentially what this script does. And you can access properties, functions, methods, whatever you want that way. And you can see that here I'm passing this object and I'm getting this location from it, right? So it's a one-liner in the end, but you just have to know how to use reflection, right? And this is here. Even if something, I think even if something is marked as private in the code, you should still be able to reflect it, which makes a lot of problems when you want to have like a secure bank application made in .NET or something like that. It's not so trivial because of reflection, but you can access anything with reflection. So here, we have X, which is object. I get the type of it, so this is agent type. Then we get the property location, and I have this property. You can actually say that you can see what this property is. So it's like a meta values of all of that stuff which is in the agent. Is it readable? Is it writable? There is like some custom attributes sometimes for properties and so on. So it's all in here, but this is how you can then pass it. I think for like most like common use, JSON will be better. Like it requires less of a hassle, and JSON in the end is used all across the internet. So sending anything by JSON is usually the simplest way. I think we have like 15 minutes left. Maybe it will be a bit longer for the Q&A. If there are some questions, then please ask. And if there are no questions, maybe we can do some more. But yeah, if you have any questions to the code which we did, we were supposed to have like a 15-minute Q&A right now. Okay, I'll just go through the open questions on Q&A. Yeah, there is a question on books. So there is a question about recommended books. Well, to be honest, when I started to code, I read a book by one of the former Microsoft employees who wrote Visual Basic. This book had 1,000 pages. I went, without knowing a single thing to how to code, I went through 600 pages of it just to get some idea how to program it all. And after those 600 pages out of 1,000, I sat in front of Grasshopper. I knew that Grasshopper has Visual Basic, and I just, what I did, I essentially did like that, right? So Visual Basic has a bit different syntax, but like once I discovered that I can do that and it will output 2, I just started to code and then refer back to that book at some point. But the beginnings are, with that webinar, I think that if you start with like no knowledge of C#, like I think that webinar gave you like at least half a year boost or even more. Like, yeah, so I hope so. But yeah, this is, I started with essentially 1+1 and then just building on that, just looking how to do stuff. But I think finding a good way of learning is to create yourself a challenge which will be hard, but also at the point at some more or less how to do it in a logical way, like logically how to deconstruct it, but then just get to know how to do it, right? And you can help yourself with like asking on the Grasshopper forum or actually looking for some particular Stack Overflow topics or tutorials online. But I would say that this webinar essentially gives you like a huge boost. So yeah, especially with the functions, creating classes, inheritance, like inheritance, essentially copy pasting the code from another class. This is like the best explanation of inheritance. It has a lot of like quirks, how to inherit and what to do with different things. But if you understand the principle that it's basically copy pasting code from another class, this gives you like 95% of what you need to know. But yeah, I think that the key is to always define a problem which you want to do, like something very precisely described in text. Like you can write your own description of what you want your code to do. So essentially write a pseudocode, so-called pseudocode, and then simply try to code it with C#. Like try to start from the part which you know how to do, right? If you have some agent, maybe you want the agent to walk in a maze, you would have to define, okay, what is the maze? What is it constructed with? Maybe it's a mesh. If you want to have the agent which walks in the maze and it doesn't pass through walls, then you need to know how to collide it with the walls, right? So maybe you go to Rhino Common, see how to collide a mesh with a point, right? So this is all about like choosing the right problems to solve on your own. And I think this is like the best way to learn. And this is like the most satisfying way as well. Because yeah, if you follow someone like one-to-one all the time, it just doesn't give you this the pleasure of accomplishment, right? So yeah. So books are cool, but I would buy the thickest book on C# right now. I mean, exactly as I did. Buy the thickest book you can find in the library. Just put it next to you, and if you are stuck with something, you can take a glimpse into the book, and then it will be fine. Uh, yeah. So. Uh, How to use commands from there? Okay, so Rhino Common. So I think that we sort of touched Rhino Common a bit. I showed you the website. I showed you that all of Rhino Common is actually accessible through IntelliSense, right? But sometimes you may want to look on the website because there is a search function, right? And if you want to have a mesh, you can say a mesh. How can I create a mesh? You have this way, right? Some static methods. And you have a direct method just as we did. So, right, just like we did before. And you can just add vertices and faces, just like you do in Grasshopper. Now, when it comes to static methods, there is maybe one good thing to show. So if you have mesh methods here, this always like I never really understood what it means, but this is static. Okay, it's important because you will not get this compute thickness when you call the particular mesh, and it's quite confusing. So you cannot say nm compute thickness, right? Because it's a static method and it will not appear. And this is, I remember that being like very confusing to me, why it's not visible here. You have to access it from mesh.compute thickness, and then you want it to compute thickness for a particular mesh or actually a bunch of meshes here, right? So it's good to understand that in the documentation, those symbols are meaningful, right? So public method and its static method. So static is important here. Do you have a class from a library or should we define it? Yeah, so there was another question with class from a library, and this is actually what we did with Newton soft with JSON. JSON convert is just a static class which we use to serialize and deserialize objects, right? You can you can download any library. I can't really think about a good library right now, but maybe Clipper, right? Clipper lib is like a very good library where you have offset functions here. And if you where to download it? Yeah. When you download it, you can have 1 second. SourceForge. I'm not sure if this compilation is for .NET. Oh yeah, it should be fine. So if you download the library, the the procedure is always the same. You download some library, then you go to the C# component, right click, add reference, and yeah, sometimes a library will also refer to some other library, so it can be a bit problematic to uh, get all the right references, right? But usually when you have a library which is coming pre-compiled, it will come with all the libraries in the build folder. So I want to put it on the desktop first. So here, new folder, and let's say Clipper, right? So just to show you how to, like, Newtonsoft is one, just another one here. I want to, yeah, it's a bit time consuming, but anyway, we extract the library. Not all the libraries will come pre-compiled, so it's also quite tricky. If you don't want to compile, you can use NuGet. So NuGet gallery is like a gallery of libraries. You can access it from Visual Studio, but here you can have, let's say, Grasshopper. I think, oh, okay. Not sure if owl is still there. Yeah, it's here. So you can download it here as well, download package. Oh, it's actually a new package. Okay, you would have to use a Visual Studio, but, or maybe this package is, yeah, I think you have to have this package explorer to get this because it has all the stuff. But anyway, NuGet is one way of getting libraries. So you can download the package. There is this package editor, but just to show the Clipper. So we extracted Clipper. There is a Clipper C# folder, Clipper libraries. Wait, it doesn't have the compiled version. Okay, that's not a good idea. Okay, there is something here. So there is the console demo, and in this console demo, there is actually a binary build of the Clipper library. I think if you look for like Clipper library build online, it will also find you this, but this Clipper library has no other references as far as I know. So you find the DLL essentially, and then you put it to use by using manage assemblies, then putting this here, right? And I see there is this Clipper library, so I put it here. And now I have to write using Clipper, I think it's Clipper lib. And now, just to see the entire namespace, you can see there is like int points, so there is like a different point. Right, so this int point is actually coming from Clipper right now. And this is how you just add it to reference. The DLL is always useful to put using. If there are two types of the same name, like point3d, for instance, that might be also in another namespace, you would usually want to have like a fully qualified name. So Clipper lib int point, right? Because it will be, let's say, similar to Rhino geometry int point. If there was an int point in here, right? Int point is like two integer values, right? So anyway, so this is how you use other libraries, how you manage the dependencies. Yeah, I think that's all of the questions which we have open in the Q&A. We have 5 more minutes. Maybe we can, if there are no questions, like we can just go for like 5-10 more minutes. I can show you like some stuff, quick stuff, which maybe we can add to the agents. So it would be nice.
Maybe show them like 5 or 10 minutes more, and then we can also see if anyone wants to ask anything on the camera.
Sure. So yeah, so one thing which I really like is a custom display in Grasshopper. And when you code in Visual Studio, it's more or less the same. But with Visual Studio, what you can do, what we cannot do with scripting, is define our own custom classes. And custom classes are really cool because you can pass them around in Grasshopper, and Grasshopper knows how to display this class, how to bake it, and what can it do with that, like transform, morph, and so on. You can define all of that in the custom class. So an agent could be technically a custom class. But sometimes you don't really want to do it's quite a lot of work to create your custom object, but still you want to have some nice visual output, and maybe you want to display the agent in some particular way. And for that especially uh, is this 1 second, just so we don't miss it. Okay, maybe outputs are not really important anymore. We can just, or maybe, you know what, let's copy this code so that you have this and also the stuff which is coming up. So this, yeah, I should probably, like, somehow during the week I mean, I can send it to you as it is right now, but I would also like to label each of those scripts, uh, and maybe send them to you with some nice labels. But anyway, we have this. We don't need the outputs because, well, we use the output just to see what the agents are doing. But if we want to have a custom display, maybe we can just create it somewhere here, right? So we have, yeah. So we have the agent and the field and helpers here. And notice if you have this I here, preview override, you can actually override the way this display for this component is working, right? So you have draw viewport meshes and wires. We will want to use wires just for polylines and maybe some arrows or whatever. And then you have the clipping box as well. So we will need to define what is the clipping box, but I think that well, we have the spawn box. Yeah, we'll do the clipping box as well. So let's say um, I will do something like that. Is it correct? 198. Oh, right. So this clip box will be here, right? So why do we need the clip box? It's a way of optimizing display in Rhino, right? It wants to know where more or less you want to draw something, and if it's not visible in the camera, it will not get drawn. We don't want to draw meshes, but in draw viewport wires, we want to draw some agents. Now, the good thing is that the agents are defined in the same scope, right? So they are accessible to this function, right? They're accessible here because they are defined here. So outside of the curly brackets of this function. If they're outside, they're accessible. So, well, first, if the agents are not defined, or if this is an empty list, we want to make sure that it doesn't happen, right? So, if agents, so if the list is not even instantiated yet, so there is no list at all, there is just a place for it, like a placeholder somewhere, but it's not existing yet, we want to return. Okay. If agents, I mean, yeah, and then for each agent. Oh, come on. Agent in agents, right? And we can use them from there. Well, we want to draw something, right? So let's see, arcs. Arcs is this parameter which we have here. It's passed, right? It's some preview arguments. Arcs display, draw polyline. And yeah, we can have polyline. Yeah, let's do it. It's not going to be super, like, the proper way of doing that is to store the polyline in the agent somewhere and get it update it with the movement, but then only access it from viewport. What we are doing here is kind of not really that nice approach where we construct the polyline in the display function. I mean, can be a bit slow, but I mean, the slowdown will be really visible with a lot of agents. Right? So new polyline, AG, history, and new draw polyline has also some custom arguments. So you can say what is the color and thickness. So let's say I want to have system. Yeah, with system drawing namespace, you have to fully qualify it, I think. So system color, well, let's say pink, hot pink. And in thickness, let's say 3. Okay. And now for the clip box, well, I think it should be already visible, but let's double check it. Yeah, it's already visible. But just to show you, because usually when you don't have any other geometry in the viewport, you should return a proper clip box. So the clip box, well, first of all, it needs to go here. We always reset the clip box by in the beginning here. So clip box is bounding box empty. Okay, we always say it's empty in the first run in the run script, and then we want to here clip box or actually bounding box union. Oh, 1 second. I'm sorry. Clipbox union. So add another bounding box to it, right? AG or maybe new bounding box. AG history. I think bounding box has this constructor with a list of points, right? Let's see. Yeah, I enumerate both points. So AG history should be fine. Okay, and that way we just make sure that this custom display will be visible, because we really need to define this properly, right? So this is just pink polylines, which is fine. I mean, it's okay, but we can do some more, right? So we can say that, well, maybe it's 1, and then arcs display, draw arrowhead, maybe. And now the point, tip, and direction. Okay, that's not so. Screen size, world size. Okay, so let's say, yeah, we certainly will have like a point 3D. Let's say point A will be AG history last. So AG history, count -2. So last point from the history, and then point 3D PTB will be the AG location. Now we will have a problem if the history is 0, so we need to say if AG history count is smaller than 1, continue. Continue means that we skip that code and continue with the next agent. Okay. So we say that here location and this and here. So point, the tip is actually PTB. The vector is PTB minus PTA. Color will be system drawing color, I don't know, let's say blue. Screen size, I mean 15 pixels will be fine. And let's say 0 because it's either screen size or the world size. Let's see if it works. Doesn't crash. Okay. Yeah, so now we can see we have those blue arrows. Okay. Yeah, we can have more agents. Let's have more agents. Now, what is cool about this display is that you don't need to display You don't need to output any geometry here. And if you don't know already, Grasshopper is really bad with huge geometry. So if you have like millions of points and you want to output them in any output or input them to any input, it will get super slow with like hundreds of thousands of values. So sometimes, like I remember I did this code where I run some code on GPU, but I displayed in Grasshopper through that C sharp, display override, and it worked with 1 million points. And I didn't want to output those 1 million points because I knew that it would be like the bottleneck in the entire process. So I just wrote this custom display routine in the C sharp script, right? Because displaying it that way is much faster. And you see that here also, it worked quite fast, right? Like we have like quite a really nice, nice speed here, right? Yeah. Let's see here, right? Okay, so any questions? I think there is no more questions. So what I will do, I mean, today, maybe not really today, but I will send it right now as it is. Send it to you as it is. And then during the week, I'll try to clean up this code a bit. So like write the proper labels for each script and then send it again to you just so that you don't get confused, right?
Hey,
Yeah,
that was really really fun stuff there.
good, good. We did like
Uh,
95% of the stuff which I prepared, and then we did with the display and JSON. I think it was just a bit we went through a different direction, let's say.
yeah, let's see. Does anyone want to ask any questions live by your camera or recording? Just raise your hand and we can bring you in as an attendee. No one? Come on, it'll be fun.
Yeah, I think it was like a lot of information. We have
Come on, now's the time.
yeah, it's good, it's good. But you haven't recorded, so I think like I know that there was a time or two where I talked a bit too fast,
Yeah,
but
it's okay.
yeah, I try to at least try to repeat a couple of things a couple of times. So
Yeah.
yeah, yeah,
So
it's
I don't
also hard to
see.
follow with typing. I know it's hard to follow with typing, so it's always a challenge. But maybe like with the recording now, you will be able to just pause it
Yeah.
and just follow that one to one. Okay. Okay. Yeah, I think yeah. Let me send it to you, Mike.
Yeah, send it to me. I'll send it to them as it is.
Yeah, and
Uh,
get it nicer. Wait, am I still sharing this screen? Not really. Just a second. Yeah. Yeah. Then I mean, I need like a couple of days just to catch up with everything, but
no worries.
I'll just do it over the week.
Well, while you do that, we'll. No one has any more questions. I'll just share real quick again. For anyone that wasn't here in the beginning, thanks for joining the webinar. It was really great. I learned a thing or two as well watching it. And also, if you're interested, please check out our master's degree here on our website, the 9-month fully accredited online master degree in computational advanced design, in which Mateusz is one of the tutors as
Yeah,
well.
I'm actually
Uh,
maybe if I can interrupt, I'm actually
yeah,
going to follow on that webinar, and we are gonna wrap that code into a Grasshopper plugin. So we'll just write a plugin for that class.
yes, and that's part of cosmogony chapter, along with Madeline.
Yeah,
So it should be pretty crazy webinar, pretty crazy chapter, to be honest, between both of you guys. Looking forward to that one.
yeah,
So please check that out. The deadline is in 2 weeks for the early enrollment, pricing, and to apply for scholarships. And I just want to mention that we have 4 new webinars. If you're interested, please go check those out. Generative design with topology optimization with Fusion 360 and Grasshopper, biomorphic networks, which is a custom plugin by Madeline called Nuclei, written just for the webinar, which is working with slime mold logics. We have Fragmented Fictions, which is a Houdini webinar with Zenep Tupao, who's really talented, looking at procedural massing. And then we have Elaborate Sinuosity with Nicholas Turchi looking at, from Sahadi Architects, looking at Maya modeling for architecture. So definitely check those out. And right now, until the 20th, they have early registration pricing, and you can find out how to get that if you go to each one at this link here. Follow that to Instagram, and it'll have instructions how to get that early pricing. So that being said, and no hands raised and no more questions.
Yeah, that's, I mean, it's either good or bad.
No, I think it's good. They're in the comments saying they like it, so
Yeah.
People are excited. I think C# is just one of those things that
Yeah,
you
it's
get
hard to
hit.
start.
You get hit with the face with it, and you kind of have to
Yeah.
realize what just happened to you before you can.
Yeah, I remember like the first year was like nightmare. Like,
Yeah,
and
well, I
then
mean, it's
like there was no workshops. Like we were doing the first workshops, right? I think there was like one or
yeah.
two companies doing like Grasshopper workshops at all.
Well, it's like learning a new speaking language. It's like you got to start somewhere, right? Like, where do you start? You just got to start somewhere,
Yeah.
and then it just comes with practice.
Yeah. Yeah, but I think like especially that like that approach where you like define your own problems and try to solve them with code. I think that this is like in Grasshopper, especially in architecture, like this is really what gets you moving forward fast. Like
Yeah,
really well because you like you know on your own like just scripting on this for the sake of scripting is not really enough.
you have to have a goal in mind.
Yeah.
I mean, you know personally because we've been friends a while. How many times I tried to learn C# and just like dropped it or didn't. But then once I had the goal in mind, which was like the things I wanted to make with Pufferfish, it was like having that goal accelerated my learning so quickly. Because I knew what I wanted to do and was able to like look up the things and research like that.
Yeah.
Because it's just too big to like aimlessly
Yeah,
look at
yeah,
things.
it's too big. Like you really get how do you say it? Like overwhelmed by it
Yeah,
if you try to like learn everything at once. But like
yeah,
actually like defining those like very specific goals and very specific like scripts which you or functions, it's like it limits your interest to only the, you know, like 5 classes, let's say, right? And
yeah.
then you learn everything about those 5 classes and how to use them, like a point and the vector and line, and it you know, and then you get those, and this gives you like a foundation to do something more. So
Walter is interested to hear about your PhD.
oh yeah, my PhD. Maybe we can skip the recording here, but
Yeah,
anyway,
it's okay.
my PhD is about AI and. I mean AI or machine learning. I think generally AI, and the topic is representation methods for AI in architectural design. Maybe it will be replaced just with design, not architectural design, but just generally design, because it's quite a basic research, to be honest. I mean, basic as in yeah, foundation research, not basic as simple. So the thing is that what yeah, what I observed in so far was that there is not really that many AI tools in architecture or design being used. The one which we know is like Galapagos, for instance, or digital. Wait, what was the other one? Generative design from Autodesk, where they are mostly like optimizing structures or optimizing something. but there is way more like neural networks. You probably heard about that, like deep neural networks and so on, which is used in like a lot of different disciplines, from like medical imaging to self-driving cars, text recognition, and so on, speech recognition. And I was just like wondering, why is it not being used so much in architecture yet? And so the question, this is the question, right? And then I'm analyzing, like I analyzed quite a lot of literature, close to 400 publications. Like, what was the topic? What was the tool? What was the result? And was there any follow up on that? And from the analysis, that was mostly like architectural research publications. So from that analysis, I more or less understood why nothing really works in architecture, and now I'm trying to fix it. But I mean, fixing it by small steps, of course. I don't want to fix everything, but I want to at least try to make one step in right direction, even if it doesn't lead to any like tangible results, right? It's more about pushing the discipline rather than accomplishing something, right? So yeah, like ages ago, we had expert systems, for instance, and the problem with expert systems in generally in not only design, but with expert systems, we had a problem with experts. So we couldn't force experts to actually give us their knowledge and write it down for us, for computer scientists, and that was a problem back then. So you can have a perfect expert system which could do everything with a proper data set or information or knowledge base, but you have to get the knowledge base, and it takes years to develop some. So then we have machine learning, which kind of overcomes that, where a machine learns from a data set, but then again you need a data set. So then we have architecture which tries to get some of this and some of that, but we don't really have data sets, and we cannot really define really what architecture is about, right? It's a very it's a very subjective thing, right? So my task right now, like last year, I was doing that analysis and all of the stuff which I'm talking about, and right now what I'm trying to do is to create some database for machine learning with architecture, right? So this is what I'm working on right now. Having a
Sounds
simple
intense.
database. What I can tell you, like the database will be open sourced and accessible to anyone, so you will be able to download it, and it will be like right now the one database which I want to create, which I think like it's quite common in literature to see like layouts with connections between the rooms, right? And this is just a graph. So I want to create this database of apartments with different graphs and just have it available, right? And because it's not there yet, right? It's a very simple thing, and everybody in like a lot of people in different papers write about that kind of knowledge representation graphs, right? But no one really does that kind of database because it's just time consuming. So I feel like a monk just sometimes, just doing stuff. It's a lot of work, just manual labor basically. But yeah, I'm using some of my students to do that. So, yeah. There is a question about OWL dedicated. We do sometimes webinars about OWL. Not. I do quite a lot of workshops about OWL, but this is what I do in like the schools which I teach at. With design morphine, I think we had one or two webinars about OWL, right?
Yeah. Well, I think it was a workshop,
I'm sorry.
right? It was a workshop.
Yeah, we had a workshop as well. Like I can't remember right now.
That was in Dubai.
Oh yeah, so Dubai was 4 years ago.
Yeah.
Or 5 years ago. Yeah.
Yeah.
So, but we may consider doing some more. But yeah, workshops are time consuming. let's,
Yes.
let's say, like
Yeah.
it's. I try to only focus on a couple of workshops, but I'm also teaching in different schools, and yeah, I don't want to leave any of that. But I also want to I only have two hands and one head.
Unfortunately,
It's hard.
because we could use more plugins from you.
Yeah, but
Well,
I
I
think
think we should.
webinars. I mean, webinars like that, which we did today, is fine because it's like it's convenient. I don't have to travel for like 4 days somewhere and then leave the everything behind because I run a regular business and I have deadlines at clients and everything, and it's just hard to forget about it for a week, for instance, right? With
So
teaching students is regular, so I just do it weekly. It's like a few hours every week, or maybe it's not destroying my calendar, my schedule.
what's your website?
The object.co, but it's very outdated, very very outdated. We usually work with clients under strict NDAs, so you can see like just the tip of the iceberg there. It's all the stuff which I managed to get my clients convinced to publish.
I'll put it there in the chat. Well, I think we should end this thing
Yeah, it's late.
because my internet also is like just it's like snowy here and for some
Yeah,
reason.
good,
uh,
good. Okay, have a good afternoon
and
and for me
yeah,
it's evening. Yeah,
and just lastly, you'll receive the recording and this file once Zoom finishes
yeah,
processing it. It'll be emailed.
yeah.
Cool. Okay. Well,
See you
thank
guys.
you. Thank
Thank
you
you.
everyone for attending.
Bye bye.
See ya.